Assalamu alaikum guys. Welcome to part 2 of this P5 masterclass. This is where we cover everything that you need to know before your P5 exam, and at the very end, as promised, we're gonna cover an entire complete past paper so we can apply all of the concepts that we have learned today and in the video before into that one past paper. If you haven't watched the previous video, I'll link it somewhere on the top right or top left, I don't know, and I'll figure it out while editing. And today we're basically gonna start with t-test. So we covered with Simpson's index of biodiversity in the first class as well as chi-square test. Let's start with the t-test. When we were looking at the chi-square test, what were we comparing or what were we trying to find out? We were trying to find out if there is any significant difference between the observed and the expected numbers. When you talk about the t-test, why is this test conducted? This test is conducted in order to check if there is any significant difference. Again, the same thing, but this time it's not the difference which we are looking at between observed and expected numbers. That was chi-square. Now we're looking at if there is a significant difference between the means or between the averages of two sets of data. So even before understanding how are you supposed to use a t-test, you first need to understand the purpose of using it. So why do we use it? A t-test is used to determine if there is a significant difference between the means of two sets of data. Now, I assume all of you guys are familiar with the word mean, right? You must have come across this many times during your IGCSEs and A levels. Means is basically just another word for the word average. How do we calculate the mean of a data set? Just calculate the total of all of the values in the data set and divide it by the frequency, meaning divided by the number of values. You got the mean of one data set. Now do the same thing for the second data set and then compare their two means, compare their respective means to see if there is any significant difference between the two means. So obviously, how many data sets are we dealing with? We are dealing with two sets of data. Now, this piece of information is very important when we find out the formula for calculating the degrees of freedom. So please make sure to remember this, and then we'll use this when calculating degrees of freedom. Okay. Now, there are some conditions when you're using the t-test. Basically, there are a few things which you need to make sure of, and only after that can you use the t-test. Number one, you should be comparing the means of two sets of data. You should not be comparing one value in one data set, the other value or any other random value in the data set. No, you're not comparing individual values. You're comparing the means. Number one. Condition number two, both data sets, both data sets must be continuous. Now, what does continuous mean? If you have learned chapter 17 properly, the first part of chapter 17 was continuous and discontinuous variation. Now, what was that? What was continuous and discontinuous variation? Basically, it's the type of phenotypic variation when you have continuous data, and discontinuous variation is the phenotypic variation when you have discontinuous data. But again, we have the same question. What is continuous data? What is discontinuous data? So let's take an example. Let's say we talk about the height of all students in a classroom. So you walk into a classroom and you are measuring the height of every single student. Tell me this. Is their height going to fall into specific categories? Meaning that the data results which you're going to get, is it going to be something like 40 students were 1.05 meters and 20 students were 1.07 meters? Is it going to be perfect categories like this? Of course not, right? Heights are very different. One student can have a height of 1.05, another student can have a height of 1.053, another student can have it of 1.06, another one can be 1.075. So what I'm trying to say is the heights is a type of data set which does not have categories. Instead, it has a very big range. The student's height can be anywhere from 1.03 to 1.09. So, what are you dealing with? You're dealing with a range. And the moment you're dealing with a range of data, that is when you know this is a continuous data type. Let me get the spelling right. This is a continuous data type. So, what could be an example of discontinuous data type? For example, blood groups. There are only four types of blood groups, only four categories of blood groups, right? Blood group A, blood group B, blood group O, blood group AB. Can someone have a blood group of ABC? Of course not. Can someone have a blood group which is between A and B? Of course not. Can someone have a blood group of Z? No. It's only one out of four options. We are not dealing with a range. We are dealing with specific categories. So, if you have categories and not range of values, this is discontinuous data. But if you are dealing with a range of values, that is continuous data. So, when you are performing the t-test, you need to make sure that the data is continuous, meaning it has a range. I'm not going to erase this just to keep it for your guys' reference. All right. Condition number three. We need to make sure that the data is normally distributed. Now, what does normal distribution or data being normally distributed mean? What does that actually mean? When the mean is equal to the mode and that is equal to the median. In other words, the mean and the mode and the median. When all three of these are equal to each other, this is when you say that the data is normally distributed. And plus, there's one more thing which you need to know. When you draw a graph, when you draw a graph for a data which is normally distributed, you're always going to get a bell shaped curve like this. So basically, the shape of a bell, right? So that's the shape of this curve right here. This is why it's called a bell shaped curve. When are we going to get this? Whenever you are dealing with drawing normally distributed data where the mean equals to the mode equals to the median. Now, think about it. Can a data be normally distributed, meaning a bell shaped curve, but the data is also in categories? Is that possible? Of course not, because if you look at this bell shaped curve, it's spread across a range of values on the x axis, right? So let's say this is zero point 0.1, this is zero point 0.2, this is 0.21, 22, 23, 25, 3, 4, 5, 6, 7. The data is spread over a range of values. So, can normally distributed data be discontinuous? Absolutely not. Normally distributed data is always gonna have a range, meaning it's always gonna be continuous. So, in other words, you could say that if condition number three is true, if the data is normally distributed, it automatically means that the data is going to be continuous. You don't have to separately go looking for that second condition if you find the mean, mode, and median equal to each other. All right. Now then, let's take a look at an example of using the t-test. Let's say, obviously, we now know that we need to have two sets of data to be able to perform this. So let's say I have one set of data, I call this group one, and I have the other set of data, I call this group two. Now, in both of these groups, I basically have students whose heights I am measuring. And all of these heights I'm measuring it in centimeters. So let's say the heights which I get in group one is 145, 149, 152, 153, 154, then again 154, then let's say 158, 160. I'm just taking a large number of values. Then again 166. Then let's do 166 one more time. Then 167, 175, 177, and then 182. Let's count how many values are these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are all of the students in group 1 and their respective heights. So 15 students. Now, let's take a look at group 2. We're gonna keep the same number of students, 15, but this is obviously another group. So, different heights. Let's take 148, then 153, 157, 161. I'm just making random numbers. 162. Let's take 162 again. 163, 167, 172, 172, 175, 177, 183, 185, and 187. Now, does it always have to be the case that we need to have the same number of values in both sets of data? Of course not. You can have different numbers of values in both data sets. You could take 16 here, 15 here. You could take 2000 here, you could take 10 here. It doesn't make a difference. But just for keeping it simple, we took the same number of values. So can we say that n1 here is 15, wherein n simply just refers to the number of values? So why have I written n1? Because that 1 is representing group 1 or data set 1. So if you try to translate this into a sentence, it means that the number of values in data set 1 is 15. So meaning the number of values in data set 2 are also 15. Right. Now what you're gonna do? You're gonna find out their mean. Very, very simple. Take a calculator. Add all of these values together and divide by 15. Then do the same thing for group number 2. Now, what are the two things which you have got? You have got the number of values for both data sets and you have the means for both data sets. Right. Now let's look at the steps we will do to calculate the t-value and basically using the t-test. Step number 1. Just like we did in chi-squared, before you perform, just remember this is a rule of thumb, yeah? Before you perform any statistical test, whether it's the Lincoln's or not the Lincoln's index, whether it's the chi-squared test or the t-test or whatever, you always make a null hypothesis. Now, why do we do this? It's because think about it. If you are not if you're not making a hypothesis, what's the point of doing it? Hypothesis, what does it mean? It means you are assuming that, oh, this might happen, but let's see. If it does happen or if it does not happen, we can confirm that by doing the experiment. But if you are not even assuming of something, what's the point of doing the experiment, right? You're doing the experiment either to prove yourself right or wrong. But if there is nothing to prove, then there is no reason to do the experiment. So you always make a hypothesis. Now, all you need to remember for chi-squared and t-test, you don't just make a hypothesis, you make a null hypothesis. And remember what the word null means? Null means of no significance. So this hypothesis is basically of no significance. What was the statement I told you guys to write for chi-squared? Null hypothesis. Let's go back to it. There is no significant difference between observed and expected values. What are you going to write for the t-test? There is no significant difference between the means of the two sets of data. There is no observed, expected, and t-test, right? It's the means that you're comparing now instead of observed and expected. So there is no significant difference. It's almost the same as chi-squared, by the way. There is no significant difference between the means of two sets of data. Now, the most popular or the most question I get asked is, if we are calculating the means here, why can't we just tell it ourselves? Why can't we just say, for example, let's say the mean you get, I don't know, is, I don't, let's say 11. And let's say the mean you get here is 13. And now you could be like, oh, there is not much of a difference between 11 and 13. Then why are we doing all of this? When you could just predict it yourself if there is a significant difference or if there is not a significant difference. The thing is, again, the same point as the last class. Finding out if there is a significant difference or not by yourself, like based on your opinion, it's subjective, right? Some people could say that 10 and 15 there's no significant difference. Some people could say 10 and 10.5. Oh, that's a very big difference. It's a very subjective thing, right? Just like the way we perceive colors. Some people look at the color blue and they're like, oh, this is blue. Some people are like, no, this is not blue. This is light blue. Some people, this is turquoise. And color blind, they can't even see the blue, color blue. So it's different opinions. It's very subjective. So it's always a good practice in biology to use a test to then prove that, okay, this is significant, or there is a significant difference, or there is no significant difference. I hope that makes sense. Okay, so you made a null hypothesis. Now, step number two, and we have already done this step, that is to note the sample size of both data sets. Sample size means basically the number of values. So n1 and n2. We already calculated this, right? So step 2 is automatically done. Step number 3. Determine the means of both data sets. We have already done this as well. Right, then what's step number 4? Now, in the exam, you will not really be asked to do this step 4, but it's a good thing if you know it, which is to determine the standard deviation of both data sets. Let me write the full form here, in fact. Standard deviation of both data sets. Now, what's standard deviation basically? Standard deviation, this is not something fancy, something difficult. No, this is really, really simple. Imagine if you have 5 values, 1, 2, 3, 4, 5. Yep. Assume these are 5 dots representing 5 values. And this dot right here is the mean of all of these 5 values. Now, if I ask you to find the difference between the means of all of the values and each individual value. So find the difference between this and this. Find the difference between this and this. Find the difference between this and this. So if we take real numbers, let's say we have the numbers 2, 5, 8, and then 3, and then 4. 2 plus 5 is 7, 7 plus 3 is 10, 18, 22. What's 22 divided by 5? Let me just pick out a calculator. 22 divided by 5 is 4.4. Now, if I ask you, what's the difference between 5 and 4.4? You would say 0.6. What's the difference between 3 and 4.4? 1.4. What's the difference between 2 and 1.4? 2.4. You get the pattern? Finding out the mean and then finding out the difference between the individual values and the mean. That's basically what standard deviation means in a nutshell. You don't have to calculate standard deviation, it will already be given to you. But this is a step that you should remember. That's what we do. Okay, step number 5. Now you're gonna have to do this in the exam. Determine the t-value. Good news, you don't have to remember the formula. They're gonna give you the formula. What's the formula? So if you're calculating the t-value, you first write the mean of the first data set. So this right here. Then you subtract it from the mean of the second data set. This right here. Now, some students get confused in this. They're like, what should we assume to be our first data set and what should we assume to be our second data set? So, why should we say this is first? Why not this? Because if you're subtracting, you can get a different answer, right? So, what do I mean by that? Let's say if the mean for this is 10 and this is 15. Now, you assume this to be your first data set and this to be your second. So how would the answer look like? 10 minus 15, which is minus 5, right? But now, if let's say you assume this is my second data set and this is my first data set. So now you're going to do 15 minus 10, that is 5. Once you were getting minus 5, now you're getting 5. You're getting different values. So, how to get rid of this problem? This is where we use the concept of absolute values. Now, again, this is something which you don't need to know, but when I draw these two borders, right, when I draw these two sticks or two lines, any negative value inside of these two lines is going to become positive. So let's say if inside of these two lines I have the number minus 5, this will become 5. And if you already have a positive value, this is going to stay as a positive value, right? So think of these two sticks, these two lines. What is the mathematical term for it? Absolute values. So think of these as a machine. Any negative number is inside of it, it converts it into a positive number. So now are you getting the same values in both cases? No matter which one you assume to be the first or the second data set? Yes. So don't worry about it. That okay, should I make this my first one or this my second one does not make a difference. So you take the mean of the first data set, subtract it with the mean of the second data set, take the absolute value and divide it with the square root of standard deviation of the first data set squared divided by number of values in the first data set. Plus, now do the same thing with the second one. Standard deviation of the second data set squared divided by number of values in the second data set. Take the square root of all of it and divide it by the difference of the mean values. This right here is the t value. Okay. Step number 6. So again, you don't have to remember the formula. It's just plugging in. They'll give you the standard deviation of the first data set, plug this here. Second data set, plug this here. How many values in the first data set? How many in the second data set? Mean of the first, mean of the second. Simple as that. Absolute values, you don't need to put this in the calculator. Now you know what importance do they have. Step number 6. Finally, last step. Calculate the degrees of freedom. When we were looking at the chi-square test, what was our degrees of freedom formula? V equals C minus 1. And how did we explain degrees of freedom? Let me just give that example again. Let's say I have 4 values, right? You could pick any 4 values, but the catch is that their total must be equal to 30. Now I can take any value as my first one, let's say 7, then let's say 10, then let's say 4. I had total control over the first 3 values. I could choose any of the first 3 values I wanted. But now think about the fourth one. Do I have control over it? Can I choose any number I want? No. I need to choose such a number such that my total comes up to 30. So 10 plus 7 is 17, plus 4 is 21, plus 9 is 30. I can't just not write 9 and write minus 3. Not possible. I need to write 9. So out of 4 values, how many did I have a control over? 3. Same case here. So total number of values minus 1 was my degrees of freedom. Same case here. So 4 data sets, or sorry, 4 categories of data. Subtract that by 1. You have control over 3 categories of data. And that was the reason behind V equals C minus 1 in chi-squared, wherein the degrees of freedom is the number of categories minus 1. But then tell me this, in the t-test, are you using one data set or 2 data sets? You're using 2 data sets. So you do the same thing twice. So V equals C1 minus 1, and then V equals C2 minus 1. And now, when you just add these two together to get the overall formula, this is C1 plus C2 minus 2. And that right there is the formula to calculate the degrees of freedom in the T test. Hope that makes sense. All right, even if it doesn't, just let me know in the comment section and I'll be able to help you out. Now, Step number 7, this is a formality. Use the T table of values. You basically have everything. Now it's just time to get your answer. Use the T table of values to accept or reject the null hypothesis. This is pretty straightforward, right? The exact same skills which you used in the chi-squared. I'm not even going to draw the table again. It's time wasted. So take a look at this. This was the table for chi-squared, right? You have the p values. What was p? P was that probability that the null hypothesis is true. As you go towards the right, you see the p values decreasing. As you go towards the bottom, meaning from top to bottom, you see that the degrees of freedom are decreasing. So what do you have to do now? You now know your degrees of freedom, right? C1, the number of categories of data in the first data set, plus C2, categories in the second data set, minus 2. Once you're done with that, let's say your degrees of freedom was 4. Now, this is the row which you need to focus on. You do not need to focus on any other row. So, let's say your degrees of freedom is 4. Now look for the critical t value. All of these values are t values. What is the critical t value? Critical t value is the t value when p is equal to 0.05. So just like here, what was the critical chi-squared value? This is the chi-squared value when p equals 0.05. So this is what you have to look at. Now, compare your t value to this t value. If your t value is higher, this is important. If your t value is higher than this t value, what do you have to do? You have to go to the right. Yeah. When you go to the right, the values increase. When you're going to the right, see, the p value is decreasing. And if your p value for your t value results in the probability that the null hypothesis is true, which is p, being less than 0.05, you reject the null hypothesis. Let me explain this again. You got your degrees of freedom. You looked at the critical value of t at p equals 0.05. Let's say this was 4.3. And let's say your value, which you did by all of those calculations and formulas, was 5.7. Now, first question, do you need to go to the left or to the right? You need to go to the right, because when you go to the right, that's only when the values increase. When you're going to the right, look at what's happening to the p values. Are they decreasing or are they increasing? They're decreasing. Now, this was when p was 0.05. If you go beyond this, think about it. Is the p value automatically going to become less than 0.05? Yes, it will be. So let's say it's going to be 0.003. I don't know. It's less than 0.05. And that's the only thing you have to look at. If your p value is less than 0.05, reject the null hypothesis. But if, let's say, it is more than 0.05, how is it going to be more than 0.05? When you have to move to the left, when your t value is lesser than the critical value. Now you accept the null hypothesis. There's also a third case. When your t value is the same as the critical value, then what's the p value? 0.05. Even in this case, you accept the null hypothesis. So less than 0.05, reject. More than or equal to 0.05, accept the null hypothesis which you made in step number 1. I'm sorry if it was a bit repetitive. I just needed to make sure you guys got this P thingy or P concept absolutely perfectly. This is free marks. Please don't lose this in the exam. Right. Now let's move to the next topic, which is called Lincoln's index. Now, what is Lincoln's index? This right here was the name of the guy that discovered this formula. And why is this formula used? What's the purpose? This formula, the index basically refers to formula. This formula was used or is used to estimate the population size of mobile organisms. What does the word mobile means? Mobile means able to move. They move really, really quickly. Now, it's not really about their speed that we're talking about. We're saying that they're able to move from one place to another, right? So, all of you have learned the topic of sampling, right? If you haven't, I'll link the playlist somewhere here on the top right. So, what did you learn in sampling? In sampling, you basically collect the organisms that are inside of the quadrats. And how do you collect it? Using different sampling tools. Let's say you use a trap, or you use a pooter, or you use nets, right? The different sampling tools you collect to collect the organisms. And then once you've collected them, you analyze them using dichotomous keys, and then you classify them. However, let's say you go into a forest and you lay down the quadrats, the basically those square shaped frames where you pick out the organisms from for your analyzation and for your sampling process. Let's say you have to figure out the population size of rats, right? Rats, or you could say mice. But the thing is, rats or mice, they can move really quickly from one place to another, right? So let's say if you are in this really, really big forest, if you're right here and you place the quadrant here. At the time of placing the quadrant, the mouse was here, but as soon as you place the quadrant, the mouse got scared. And then it moved from this place to this place. You had the mouse in the quadrant in the first place, but now it has changed its position. If that's the case, how are we going to estimate their population size if we are not able to keep them in the quadrant in the first place? Right? Make sense? So, you need to trap the organism which is mobile. And once you trap them, we'll figure out how to trap them in a second. Once you trap them, you then count them. Then you re release them. And then you count them again. This was the crux of the entire method. Now let's look at it in detail. So, step number one, you first collect a sample of organisms using nets or traps. You can't use pooters here, right? Pooters were a sampling tool that was used to collect very, very small organisms, let's say small insects or small ants. You can't collect a big rat or a big mouse with a pooter, yeah? So you use nets or you use traps that you set inside of the grounds. So you collect a sample of organism using nets or traps. Step number one. And what are these organisms? These are mobile organisms. Now, once you have collected them, you mark them with a non toxic paint. What do? You mark them with a non toxic paint. Okay, why does it need to be non toxic? Why can't it be toxic? Obviously, if you paint them, if you mark them with a toxic paint, they're gonna die off. You don't want them to die off. And secondly, you don't want to paint with a very heavy paint. So, there are some paints which are really heavy, they have a very big mass. And once you paint those animals with such a heavy paint, their mobility is going to be affected, right? You do not want that to happen. So you mark them with a non-toxic paint in such a way that you're not harming the organisms and their mobility is not being affected. How is it going to harm the organisms? You're just marking them. Let's take an example. Let's say you have two rats that you caught using a trap, and now you mark them with red paint. Now, this is happening, let's say, in a desert. When the mouse are in a desert, and they have red color on them, aren't they gonna be even more visible now to the predators? They are. And if they become extremely visible to the predators, which they now are, the predators are gonna catch them, they're gonna eat them, and they die. So your paint essentially harmed the organism. So you need to make sure that the paint size is so small that it does not make the rat or the mouse or the mobile organism visible. And plus, it should not be really heavy that you're basically just painting the entire body. No, you do not need to affect their mobility. So you paint them in such a way that they are not harmed. Again, we looked at how they could be harmed if they become more visible to predators, and how will that happen if you apply an excessive amount of paint, or their mobility is affected. So we don't want either of these things to happen. All right. Once you have marked them, right, now you count them. How many did you actually mark? You mark every single one you trap, right? So now you count all of them, and you name these value as n1. So basically, n1 is the number of organisms which you caught in the first time. Now, once you have marked them, once you have counted them, you now release them. So release the organisms. And here comes the main part. The thing is, after you have first caught them, you then need to catch them again. But then, if let's say you caught them and you release them, and after 10 minutes you catch them again, aren't you gonna catch the same ones which you already marked? Yeah, because they haven't gone a really far distance away from you. So you need to allow a sufficient amount of time for them to mix with their population. So release the organisms and allow sufficient time to mix with their rat population or their mouse population. Now, once again, to mix with their population. Yeah. How much time is sufficient time? Is it 2 weeks? Is it 6 months? Is it 6 years? No, not that much time. You could maybe give, let's say, 2 to 3 months. That's more than enough. Okay. Now, after 2 to 3 months have passed, again, there's no need to remember the value, just use the word sufficient. You now recapture the organisms. Now, what's going to happen? When we recapture the same when we recapture the mobile organisms, some of these are going to be the ones that we have caught for the first time, meaning they don't have a mark on them. And some of these are going to be the same ones that we caught the first time. So, recapture a second sample of the mobile organisms. So when you catch all of these, now you look at their body. Do they have the paint on them or do they not have the paint on them? If they don't have the paint on them, they were caught for the first time. If they do, they're caught for the second time. Okay, this second sample in total is called N2. Now, out of this N2, there are the ones that is caught for the first time and for the second time as well, which have the paint on them. These organisms which are caught for the second time, you mark these as NM. What does M mean? M means marked. So, number of organisms that are already marked. You don't really name this, you just count them. And when you add these two together, this becomes N2. Now you can estimate the population size by using the Lincoln's index. Lincoln's index is represented by the letter capital N, and this is N1 multiplied by N2 divided by Nm. You take the sample of the first organisms which you caught, you take the number of the second organisms in total that you caught, and you divide that by the number of organisms that you recaptured, and you get the population size. So, can we say this method is called the mark, then release, and then recapture method? Absolutely. That is exactly the name of this method. However, there are some assumptions if we need to make sure that this method which we are using is valid or not. And we've already talked about 2 out of 3 of these assumptions. Assumption number 1, the paint which you are painting the organism with, right? Make sure that it does not affect the mobility of the organisms. And number two, you guessed it, the pain should not affect the survival of the organisms. It should not make them extra visible to predators. I'm just going to copy this and change the word mobility to survival. Now, number three is a bit new. We haven't discussed it. And that is, imagine this. Let's say you trap 10 rats, you mark all of them, and you release them so that they can obviously mix with their population. Turns out of these 10 rats, 7 rats migrated to another city. They're not gonna come back. They're not gonna be in your second sample because they've already migrated. That's bad for us, right? That's affecting our experiment results. You are trying to estimate the size of the rat population in the area which you are in. Now, if some of these rats are migrating to another city and then they are coming back, while they had already migrated, you had already performed your N2. So it's affecting your experiment results. So this is an assumption which you need to make sure of, that there should be no migration of the organisms, not the marked ones, not the unmarked ones. Those organisms that are in the ecosystem should remain in the ecosystem. Those which are out should remain out. There should not be basically any inflow or any outflow. Right, let me give you guys a sample question to work with, and then you can learn how to use the Lincoln's index. So I'm going to write the entire question. This is very simple. Just plug in the values in the formula. But yeah, so the number of voles collected in a particular ecosystem were 247. All of these voles were marked with a non-toxic paint and then released. A second sample was then collected the next month, and the total number of voles caught in the second sample were 259. 16 of these voles, right? 16 of these voles were marked already. Okay, interesting. Estimate the population size. So just pause the video, try to attempt it, and then resume the video to see if your answer was right or not. Right, I assume you've solved it. So let's see. If you're estimating the population size, you only need to use one formula, and that is the Lincoln's index. Lincoln's index was N1. Please make sure you remember this formula. They sometimes give it in the question paper, they sometimes don't. So it's a good practice to remember it. It's the number of organisms in the first sample multiplied by the total number of organisms, not just the marked ones, the total number, divided by now the marked ones in the second sample. So how many were there in the first sample? 247. How many were there in the second sample? 259. So 259. And how many were marked out of these 259 voles? 16. And now the answer which you get is around 3998. That right there is the population size of the voles. And that is basically all you need to understand about the mark release recapture method. Now, this sometimes just comes up in a P4. You guys are done with P4, but it comes up in a P5 way too many times. Sometimes it also comes as the big planning experiment. Obviously, you guys know that, right? We'll also see it in the past paper. It's a big 7 marker or 8 marker. Sometimes it just says describe a method that could be used to estimate the population size of a mobile animal such as a brown rat. This, which I just read, was a past paper question. So now you just explain the entire method. The mark release recapture method would be used. Brown rats would first be sampled using tools such as traps and nets. Then all of the brown rats which you catch would be marked using a non-toxic paint. This is very important. The paint needs to be non-toxic. Then the animals would be released after you have counted them, and then sufficient time would be allocated for them to mix with their population. Then the brown rats would then again be resampled. You count them, you name this as M2. The first time you count, you name this as N1. And then out of those N2, the already marked ones are numbered as NN. Then Lincoln's index would be used, which is N1 times N2 divided by NM. And now you also write about some assumptions that the pain should not affect the mobility or the survival of the organisms. And you need to assume that there is no migration of any rats in or out of the ecosystem. Simple as that. Nothing more you need to know about. Right. Now, the next thing which we have to look at is what do we mean by the Hardy Weinberg equation? Now, many students just assume that, let me just check if it's recording. Yeah. Many students just assume that because this is written as equation, meaning it's written as a singular word, so that it means that, okay, we're just dealing with one equation. But no, when you talk about the Heidi-Weinberg equation, you're basically dealing with two sets of equations. Now, what are these two sets of equations? The first equation, in fact, is p plus q is equal to 1, and the second in the set is p squared plus 2pq plus q squared is equal to 1. You might recognize this from your maths IGCSE, a squared plus 2ab plus b squared. It's really similar to that. But the thing is, we don't actually know what is P, what is Q, what is P squared, what is 2PQ, what is Q squared. We're just given two random formulas. And by the way, these formulas are gonna be given in the question to you. You don't need to worry about remembering them. However, just like we said, you need to understand what each variable stands for, right? You don't, if I ask you what's Q, we have absolutely no idea. What's Q squared? Again, we have no idea. So let's take an example. Let's say I have a really big island, and in this island, I have many organisms. Now, if there's one thing common in my example, please don't remember this. If there is one thing common in all of these organisms, is that there is a gene called gene 1. Now, this gene codes for body shape. This gene, the name of this is gene 1, it codes for body shape. Now, this gene has two alleles. This is the capital B allele and the small b allele. The capital B allele codes for a triangular shape. So I'm just going to write this as triangle shape. And the recessive allele codes for a circular shape. So I'm going to write this as circle shape. Now, this is one gene that we are dealing with, right? This is not dihybrid inheritance. This is monohybrid inheritance. And what have you guys learned? Whenever we talk about monohybrid inheritance, and if there is no codominance of some sorts, then there are only three genotype combinations that are possible. Either you have a homozygous dominant, or you have a heterozygous, or you have a homozygous recessive. In homozygous dominant, obviously the dominant allele is expressed. So, meaning if any organism has the genotype capital B, they will have a triangle shape. Now, in heterozygous, tell me this, which allele overpowers the other? Of course, it's the capital B allele which overpowers the small b allele. We listen to this. and not this, because this is the dominant one. So even in this case, even if an organism has the genotype capital B small b, it's still going to be triangular shape. But if an organism has both alleles small b, this is homozygous recessive, this is going to be circular shape. So I have many organisms here. I'm just going to, instead of drawing their phenotypes, their shapes, I'm going to write their genotypes to make it simpler. Right, so this is capital B, small b, small b. Then let's draw heterozygous here. This is homozygous dominant. Just taking random values to fill up the circle, to fill up the island, in fact. And let's take a homozygous recessive. Let's take another one, and then another one. And why not another one? And then let's take a capital B, capital B. Let's take a capital B, small b, capital B, capital B, capital B, small b again, capital B, small b again. Okay. Now, how many organisms here are in total? So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. You have 19 organisms in total, and each having either one of three genotypes. Either they are homozygous dominant, or they're heterozygous, or they're homozygous recessive. All right. Now, if I tell you to count the number of organisms that are homozygous dominant, what would be the answer? So let me just go back to that island. How many are homozygous dominant? Let's count them. So we have one, then two, then three, then four, five, six, seven. Let's double check if we are not missing anything. We're not. So that's so 1, 2, 3, 4, 5, 6, 7 organisms. Seven are homozygous dominant. If you divide, now this is important. If you divide the number of organisms that are homozygous dominant with the total population, that was 19 in our case. So 7 divided by 19. This right here is equal to the p squared value. So now know that what does this p squared means? It just means how many organisms are homozygous dominant divided by total population. So in other words, it's basically the ratio of organisms that are homozygous dominant to the total number. That's p squared. Now let's understand what's q squared now. If p squared is homozygous dominant over total, then q squared is going to be homozygous, you guessed it, recessive over, again, the total population. Now you know that the total population is already 19. We already calculated that once, right? We don't need to calculate it again and again. Now, how many are recessive? So we have one, then two. We just drew a bunch here. So three, four, five, six. Have we circled all of those? Let's double check. Yes, we have. So 1, 2, 3, 4, 5, 6. 6 out of 19 or are recessive. So q squared is 6 divided by 19. Now, what's 2pq, the last variable in this expression right here? This is done. This is done. 2pq, this entire thing. So I'm not talking about p or q or 2. The entire thing, what does it mean? So this is just the number of organisms that are heterozygous divided by the total population. Now, there are two ways to figure this out, right? Let's look at the more simpler way first, which is what we have been doing all along. Just count the number of organisms. So that's one, then two, then three, then four, then five, and then six. Have we missed anything? No, we haven't. So one, two, three, four, five, six. That's six out of 19, or six over 19 is the 2pq value. That's the simple way, right? The second way is basically just using the formula. You know that the formula is p squared plus 2pq plus q squared is equal to 1. Now p squared, we know this. This is 7 over 19. 2pq, we still don't know what the numerator is, right? So that's x. But we know the denominator, that's 19, because that's the total. Plus q squared, that's just 6 over 19. Now, if all of the denominators are equal to 19, can't I just write 19 here? But then some of you guys would be like, no, this is 1. But remember this here, 19 over 19 is also just 1. If the numerator and the denominator are the same, they cancel out to give the answer 1. So instead of 1, you could write something divided by 19. When all of the denominators are the same, you can write 19 as the final denominator. And now you can add up the numerators together. And you need to make sure there is a 19 here so that they cut to give you 1. So now 7 plus x plus 6 is equal to 19. So x is just 19 minus 13, and x in here becomes 6. So now you can be like, oh, x right here, aka the number of organisms that are heterozygous, are 6, which is exactly what we counted. So that's the more smarter way, especially when you have quite a large number of organisms. So you're not going to sit down in the exam counting them, right? Just use the formula. Okay, now I'm writing a note here and I want you guys to make sure to read this. What's the note? All of these values, which values? The p squared value, then the q squared value, and the 2pq value. These are the three values we talked about so far, right? All of these values can be expressed as a fraction, as a decimal, or as a percentage. It is completely up to you, or in some cases, up to the question that in which form they want you to write the answer. You can write the answer as a fraction, just like we did in this case. You can write the answer as a decimal, just put the fraction in the calculator, press the SD button, and you're gonna get the decimal. Or once you get the decimal, multiply it by 100 to get the percentage. You could write it in any of these three forms or any of these three versions. Now, you can use these values to figure out the P and the Q values as well, yeah? We can use these values to figure out what's going to be the P value and what's going to be the Q value. And how is that? Pretty simple. You know what P squared is. P squared is 7 over 19. So if I ask you to find P, then you just take the square to the other side. So square root of 7 over 19. Same case for Q squared. If this Q squared is 6 over 19, then Q is just going to be square root of 6 over 19. But then here's the interesting part. You cannot do that in this example. Why is that? That's simple mathematics, just taking the square to the other side. The thing is, we don't have problem with the mathematics. We have problem in our particular example. Take a look at how many organisms were in total in our example. 19. Hardy-Weinberg equation works. Hardy-Weinberg, the two people who discovered these two sets of equations. This works when you have like a really, really big population, let's say 2000 organisms or 2500 organisms, or even if you're looking at a minimum, it works when you could say the population is greater than or equal to 50. Was our population greater than or equal to 50? No. So can you apply the Hardy-Weinberg equation here? No. So then why did I put this example in here? Just to, understand how the Heidi-Weinberg equation works. But now you know you can't use it if you have organism total number as less than 50. It needs to be more than 50 or at the very least equal to 50. But again, the more the merrier, like the more the better it is for you to use it. All right, now I have a question for you. So let's see if you're going to be able to solve it. Let's say you have a big island right here. And in this island, you have 2,500 cats. And all of these 2,500 cats are obviously of the same species. You can't use Hardy-Weinberg equation to calculate the total number of organisms which are homozygous dominant, heterozygous, homozygous recessive across different species. No, it needs to be of the same species, of course. That's a given, yeah. So you have 2,500 organisms. Can you use Hardy-Weinberg equation? Yes, we can, because the number is more than or equal to 50. Now here's the situation. In all of these 2,500 cats, you have a gene. Now this is a gene which is coding for the color of the cat fur. Different cats have different colors of fur, right? So this gene is coding for the color of the cat fur, just assume. And this gene has two alleles. One of the alleles is capital B. So this is the dominant allele. And the other one is the recessive allele. So which is the small b allele. Now, obviously, monohybrid inheritance, you don't have any codominance here. Only three genotype combinations exist: homozygous dominant, heterozygous, homozygous recessive. You need to be really fast at this, like make this muscle memory. So, if it is homozygous dominant, what's the fur color gonna be? Okay, I haven't told you guys this. I haven't told you this yet. Capital B codes for black fur and small b codes for gray fur. Now you can tell me if it's homozygous dominant, it means that it's black fur. If it's heterozygous, it means again that it is black fur. And if it is homozygous recessive, it means that you're talking about gray fur. Okay, now here's the question. Out of 2,500 organisms, out of 2,500 organisms, 720 have gray fur. Okay, interesting. Your question is find out the number of cats that have black fur. All right, take a moment to read the question, pause it if you want to solve it, and then we'll solve this together after you resume the video. Right, I assume you have solved it. So let's see what are the data which we are given with and what are the formulas which we have to work through. So you obviously this is a Hardy-Weinberg equation question. So you are given two formulas: p plus q is equal to 1, and then p squared plus 2pq plus q squared is equal to 1. Now, what is q squared again? It is the number of homozygous recessive divided by total population. If the cats have gray fur, doesn't that mean that these cats are homozygous recessive? Yes, it does. Because the other two possibilities are them having black fur, right? If they're homozygous dominant or heterozygous. So if they have gray, it automatically means it's homozygous recessive only. So 720 are homozygous recessive out of 2,500. If you take the number of organisms that are recessive, divide them by the total, you now have the q squared value. Okay, now let's see what else do we have. Do we have the number of homozygous dominant? No, we don't. So I'm going to write x divide by 2,500. Do we have the number of heterozygous? No, we don't. Again, x over 2,500. I'm just going to bring the addition sign here. And now we know that this is equal to something, or not something, 2,500 over 2,500. And we could make the different variables, because if we make the same variable, we are seeing that homozygous dominant and heterozygous are the same, right? And that's not the case. Can you solve an equation which has two unknown variables? x plus y plus 720 is 2500. Can you solve it? No, you can't. It's the same thing as saying a plus b is 3. It's not possible to find a or b, right? Just from this equation alone. You can say a is 3, b is 0. You can say a is 0, b is 3. You can say this is 2, 1. This is 1, 2. This is 4, minus 1. This is minus 1, 4. Millions of possibilities. You cannot solve a linear equation that has two unknown variables. So it's clear that we can't solve it using this. How about we use the second one? It says p plus q is equal to 1. Can you find q in this case? Yes, you can. Because you know that q squared is 720 divided by 2500. So if you just take the square to the other side, you now have q squared. Oh, sorry, q. So square root of 720 over 2500 equals 1. And this is added to p. Can we now find p? Yes, we can. Now think about it. Q squared is homozygous recessive divided by total. So Q becomes just homozygous recessive. Like how many are homozygous recessive? P is homozygous dominant over total. So this P squared is homozygous dominant over total. So P is how many are homozygous dominant, which is exactly what the question was asking for. So now if you just take 1 and subtract that from 720 over 2500, that is your answer right here. I don't have a calculator right now, but that obviously, whatever is the answer, is the answer to this question. Now, some of you guys might be thinking, and it's a good thing if you have this in your mind, the question said to find out black fur, how many have black fur? But black fur doesn't only mean dominant, right? It can also mean heterozygous. When did we take this into account? The thing you need to understand here is take a look at 2PQ, right? What was 2PQ? 2PQ is how many are heterozygous over total. And notice it had P and Q both in this case. P here means all of those organisms that have the dominant allele inside of them. This is important. What does P mean? P basically means how many organisms have the dominant allele inside their genotype. These can be homozygous dominant and also heterozygous. Even the heterozygous have the dominant allele in their genotype, right? So you are taking into account of both of these genotype combinations when you find out P. So can you say that P is your dominant allele frequency? Basically the number of, what is frequency? The number of times something happens, right? So dominant allele frequency is the number of times the dominant allele appears in the entire population, which is exactly what you calculated. And therefore Q is the recessive allele frequency. In fact, let me just pull up the calculator in order to just complete this answer. So it's where's my calculator? Yeah, there it is. So 1 minus square root 720 over 2500. Okay, I'm getting P as, I'm going to write it two decimal places, 0.46. And then Q is just 720 over 2500 square root, which is coming out to be 0.54. Notice when I add both of these values, what do they become equal to? 1. The maximum allele frequency. In this population, how many alleles are you dealing with? Only two, the dominant and recessive. So shouldn't they add up together to make the total? And that's exactly what they'll do. How many times does the dominant allele appear? Plus how many times does the recessive allele appear? When you combine them, you now have how many times did an allele appear in the population. So again, just like we talked about, you can also express this in a percentage. You can say in your total population, you have 46% of dominant alleles and 54% of recessive alleles. What does this mean? It means, let's say you write down that all of the alleles combined. So out of these two, in these 2500 cats, You write down every single allele in every single cat. So let's say one cat is capital B, one cat is capital B, small b, another cat is small b, small b. Just in these three cats, how many alleles do we have? We have six alleles. So it's two alleles per cat. So how many alleles for 2,500 cats? 5,000 alleles. Out of these 5,000 alleles, that is basically the total allele frequency, 46% of these alleles are dominant and 54 are recessive. Hope that makes sense. Okay, now why do we use this Hardy-Weinberg equation? Well, we use it. So let me write the question. Why do we use this formula or this equation? This is pretty simple. You use it to find out the changes in the allele frequency if any over a long period of time. What are you trying to find out? You are trying to find out if there are any changes in the allele frequency, if any, over a long period of time. Let's take an example. Let's say we have an island here, and in this island, let's say you had 2,500 organisms. And this right here is in 1990. We are in the year 1990 right now. Stone Age, right? Not Stone Age, but really back then. So, like the 20th century. And in that case, in the 20th century, in 1990, out of these 2,500 organisms, so 5,000 alleles, right? 46% of these alleles were dominant. So 0.46 is the dominant allele frequency. And 54% of these alleles were recessive. 0.54 is the recessive allele frequency. Fast forward to the same island that now has 5,000 organisms. How many alleles is that, by the way? 10,000 alleles. If you're dealing with two alleles and one gene, right? So each organism has two alleles. So two organisms, four alleles. Three organisms, six alleles. 5,000 organisms, 10,000 alleles. In that case, the dominant allele frequency we found out, oh, this is still 0.46. And obviously the recessive is still 0.54. This is in 2020. Did the allele frequency change? There was no change in the allele frequency. This triangle refers to change, right? If you've learned this in physics. So there is no change in the allele frequency. What does this tell us? It tells us that no evolution has taken place. Exactly, right? What was a synonym for the word evolution? You learned this in selection and evolution. Evolution was basically a change in the allele frequency in the total population. If let's say the dominant allele frequency had increased, or let's say recessive had increased, then we would say that yes, there is a change in the allele frequency, meaning that evolution would have taken place. But because there is no change here, it means that no evolution takes place in this case. Right. All right. So now let's move on to the next topic, and that is the topic of correlation. This is basically where we will be looking at the Pearson's linear correlation coefficient, which is really, really important, and the Spearman's rank correlation coefficient. But before we look at these two correlation coefficients, let's understand what exactly the word correlation means. That's when it will make sense, right? So, what does correlation mean? Correlation is basically a phenomena. Think of it as a process. And this process is used to determine this process is used to determine an association between two variables. So let's say I have a graph And in this graph, I have the x-axis, and in this x-axis, I have listed down species A, meaning as the x-axis value increase, the number of organisms in species A increase. And then in the y-axis, I have species B. When I draw the graph after plotting all of the points, the graph looks something like this. What is this? You've learned this. This is a positive correlation. This is telling us that as species A increases, it also means that species B increases. Or you could say as species A increases, B also increases. Here's the important question. Did I anywhere say that the increase in species B was because of species A? Did I say that? I did not. I did not say that if species B increased, it means it must have been because species A had increased. No. This statement right here is called a causal relationship. What is a causal relationship? A causal relationship is a relationship where you have a cause and an effect. Let's take a real life example. Let's say you're looking at the temperatures during midday, let's say 12 p.m., on different days. So on Sunday, you looked at the temperature. On Monday, you looked at the temperature at 12 p.m. On Tuesday, temperature at 12 p.m. On Wednesday, temperature at 12 p.m. So on and so forth. And apart from looking at the midday temperatures for every day, you're also looking at the amount of sales that an ice cream shop does at midday. Turns out, when the temperature was low, let's say 20 degrees or 25 degrees, that's low where I live. So, when the temperature was low, the ice cream sales were low. And then when the temperature was high, the ice cream sales were also high. What do you think? Is this a causal relationship? Is this relationship having a cause and an effect? Absolutely. Of course it does, right? Because the temperature increased, the ice cream sales also increased. There is a relationship between the ice cream sales and the temperature. Because when the temperature increases, the what you could say, if the temperature increases, it gets more humid, right? It gets more hotter, and there's more sweating and all of that stuff. So this is why people eat more ice creams and cold stuff in order to cool themselves down, in order to cool their body down. So is you see a relationship? There is a relationship. But take a look at this case. When species A increases, species B increases. Did we ever say that because of species A increasing, species B also increased? No. So it does not matter what do you have here and what do you have here, because this is not a cause and effect relationship, right? One factor is not related to the other. It's just a coincidence that both of these increased at the same time. They are not a causal relationship. And this is exactly what the word correlation is. Correlation does not, I repeat, it does not show a causal relationship. So, if you have understood this, then you would be able to answer my next question. If you answer this wrong, then just rewind the video and try to answer it again. So I'm going to write two statements here, and then you're going to tell me which statement is correct for the word correlation. As, oh, in fact, when species A increases, meaning as the x-axis increases, the species B organisms also increase. That's my first statement. And now my second statement is because the number of organisms in species A increase, it led to the number of organisms in species B to also increase. Which one is the correct statement? Which one is showing correlation? You're right, it is statement one. Why? Because statement one is not showing you a causal relationship. Take a look at the second statement. Because it led to Because species A increase, that's the cause it led to. That's the effect. Cause, effect, causal relationship. Correlation does not show you that. All right. Now, when we talk about correlation, we draw correlation in scatter plots, right? You must have learned this in maths IGCSE. Even if you haven't, it's not a problem. Scatter plots or scatter graph aren't really tough. It's basically just a graph, and you have a bunch of points plotted on them. Simple as that. That's a scatter plot right there. So, plots scattered. Hence the word scatter plots. Now, if I draw the plots in this manner, which type of a correlation is this? Obviously, you can see the values increasing, right? So this is a positive correlation. And if I ask you, do you see a straight line or do you see a curved line? You see a straight line. And what do we call a straight line? A linear line, right? A curved line is going to be a non-linear line. So there's no quadratic, cubic, or that sort of stuff here. It's either linear or non-linear. So positive linear correlation is being showed in this case. What if I draw a graph and in this graph the values are just going downwards? But again, in an almost straight line. This is negative linear correlation. Okay, let's take another example. Let's say I have this graph, but now take a look. The values don't have any pattern. They're just randomly increasing. So it's like this. Is this a straight line? No. So you know this is non-linear, but compare the first value to the last value. It's generally the general trend is that it's increasing, right? It's not that the last value is below the first value. So it's increasing, meaning it's positive. So this is positive, this positive, and this is the same thing. I've just written this in short form. So this means positive and this means negative, just short form. So write the word entirely in the exam, not this. So this is positive non-linear correlation. What if we draw the opposite thing? So let's say we start right from the, oops, let's say we start right from the top and then we just have a random, oh no, not this. Yeah, let's say we just have a random pattern, no set pattern like this. So generally we see it's decreasing. So it's a negative correlation and it's no longer a straight line. So negative non-linear correlation. All right. Now, let me ask you this. Which type of correlation do you think this is? If you said no correlation, you are right. Yeah, you can't really predict which one is it. Is it positive or is it negative? All of the values are just found together. There's no clear pattern or there's no clear trend you see, right? So this is just basically no correlation. Okay, what if you have a graph and it looks like a quadratic graph? Again, as I said, there's no quadratic here, but let's say if you have a graph like this, then how would you answer this? You would say we could cut the graph into two parts. This part is positive nonlinear and the first part is negative nonlinear. Simple as that. You don't need to talk about the entire scatter plot together if you can clearly cut it in two parts, right? Okay, now here comes our main topic. If you have to determine the strength of a correlation, so let's say if you have positive linear correlation here, right? Now I can draw a graph like this, saying that this is positive linear, but I can draw a graph like this as well. This is also positive linear. Oh, sorry, this. But look at both cases. In the first graph, the points or the plots are really far away from the line of best fit. But in the second graph, the points are very close to the line of best fit. So both of these are positive linear, but one is weak positive and one is strong positive. So basically, when we talk about correlations, correlations can have different strengths. It can be strong correlation. It can also be weak correlation. It can be very strong. It can be very weak or no correlation. That's basically the different values of strength. So, when you now have to find out, or let's say you have to numerically calculate and not just, look at the values and say that, oh, they are far from the line of best fit. So, this is weak correlation. If it's close, it's strong. So, weak and strong are qualitative words, right? What if you have to find out the answer numerically, like give using values? So, then you can use the two correlations coefficients to find out their strength. That is Pearson's linear correlation. That's, by the way, also the name of a syllabus, but yeah, Pearson's linear correlation coefficient. This is represented by the letter R, and then Spearman's rank correlation coefficients. And because both of these are just correlation coefficients, right? We use the same letter to represent them. That's R. But then how do we differentiate between Pearson and Spearman? For Spearman, we just put an S below it. So this is RS. So if you see RS, this is Spearman. If you just see R, this is Pearson's. But are they two really different? No, right? Both of these are used for the same purpose. Both of these are correlation coefficients, which are used to give you the value of the strength of the correlation between two variables. It's just different ways to calculate the same thing. Okay, let's talk about Pearson's linear correlation coefficient first. So let's talk about just R, not RS. Now, there's one thing you need to remember. And what is that? You need to figure out yourself. You need to figure out yourself which correlation coefficient are you supposed to use. The question is not going to tell you that. Do you use Pearson or do you use Spearman? Now, how do you figure that out? You figure it out using the criteria. Both of these correlation coefficients have different criterias, and you need to remember the points in these criterias. Number one, the data in Pearson's linear correlation coefficient, the data is normally distributed. So remember the things we talked about for the t-test. It should be normally distributed, it should be continuous, you should be comparing the means of two sets of data. What was that? That was the criteria for using the t-test. What we are writing right now is the criteria for using the Pearson linear correlation. So, condition number one, the data needs to be normally distributed. If you're watching the video up until here, you should now know what normally distributed means, that the mode is equal to the mean, which is equal to the median. And of course, you should also know if the data is normally distributed, it automatically means that the data is continuous. See, you don't have to remember each one separately. That's the two conditions. Number three, you should have at least 5 pairs of data. Now, what do we mean by pairs of data? If you look at a coordinate, how did I draw this coordinate? By looking at the x value and the y value, right? That's how a coordinate works, right? X comma y. So can you consider this as a pair of values? The x and the y together. So one x value and one y value together make a pair or a coordinate. So you should have at least 5 pairs or 5 coordinates. It's the same thing. At least, not must. But if it's less than 5, you can't use this correlation coefficient to figure out the strength of the correlation. And number 4, take a look at what the name of this coefficient is. Pearson's linear correlation coefficient. The word linear is in the name. What is that telling you? That you can only use this coefficient in those situations wherein the scatter plot or the scatter graph shows linear correlation. So remember, we looked at different examples. Let me just go back up. We looked at examples where there was no correlation or where there was non-linear correlation. You can't use Pearson for this. You can only use it when there is linear correlation. Now, which type of linear? Positive, negative, doesn't matter. Doesn't matter at all, but it needs to be linear. Now, what's the formula which you use for calculating Pearson's correlation? Now, just a heads up, there is no need to remember the formula. They're gonna give it to you in the exam. Please don't waste your time remembering it. Don't remember the formula, right? So let's write down the formula. I'm just copying it from a past paper and I'm gonna explain what each variable means in this case. Just let me just write down the entire thing. All right, let's read this formula together. Sigma xy, this symbol means sigma, right? Which basically means total. Sigma xy minus n mean of x, mean of y, divided by n minus 1. The 1 was a bit small. Standard deviation of x, standard deviation of y. First question, what is this x and what is this y? These are the values in the graph, right? X refers to the values on the x-axis. Y refers to the values on the y-axis. That's the first thing. X is referring to the x-axis. Y is referring to the y-axis. Okay, what does sigma xy mean? Remember we said you need to have 5 pairs of data at least? Well, in your question, no matter how many pairs of data you have, the condition should be more than or equal to 5. Let's say you have 7 pairs of data. So let's say you have 3 comma 4, then you have 4 comma 5, then 2 comma 3, 3 comma 7, and then 2 comma 9. Are these 7? No, that's 5. Okay, let's take 2 more. 2 comma 8, and then 5 comma 11. Okay, I don't even know if this is linear, but never mind. Again, it must be linear, right? Because the word includes the word linear. Okay, now what should you do? Take a look at every single coordinate. It says this is the x value and this is the y value. And this right here says sigma xy. What you should do is multiply all coordinates with each other. So I'm not saying multiply one coordinate with the other. No, no. I'm saying inside of each coordinate, multiply the x and y values together. So 3 times 4, 12, 2 times 8, 16, 2 times 9, 18, 6, 21, 55, 20. Right? Step number 1, multiply all of the x's and the y's with each other in each coordinate separately. Now, add all of the values you get. So, for example, 2 times 9, 18. 2 times 8, 16. 3 times 4, 12. 4 times 5, 20. 5 11s, 55. 3 sevens, 21. 2 threes are 6. 18 plus 6 plus 21 plus 55 plus 20 plus 12 plus 16. Add everything together. This is what is meant by sigma xy. But again, you're not going to be asked to calculate this in the exam. They're going to give you this entire value. So the exam question is going to be like sigma xy is blah, blah, blah. Okay. What does n mean? You now know this. Just like we talked about in the previous statistical test, n refers to the number of categories, or you could say the number of pairs of data in this case. So how many coordinates did we have here? 7. So n here is gonna be equal to 7. Okay. What is this line on top of x or this line on top of y mean? The line basically refers to you calculating the mean. So there are many ways of representing the mean of a variable, right? This is mean of x, this is mean of y. So all of the x values you have, find out their means. All of the y values, find out their means. Multiply x value means with the y value means with the number of coordinates. N minus 1, whatever coordinate number you have, subtract that by 1. Find out the standard deviation of x and the standard deviation of y and multiply them and this bracket with each other, and eventually you get r. But again, I'm just repeating this. In the exam, you'll not be asked to calculate this, or this separately. It will tell you what this entire thing is equal to and what this entire thing is equal to. All you just need to do is just divide these two values together to get R. Now, here's the important part. The R value is less than or equal to 1. So it basically has a range. It can be maximum positive 1 or minimum negative 1. So basically, it ranges from -1 to 1, and -1 and 1 are included. What is this telling us? Let's say that your R value turns out to be positive 1. This is the strongest possible correlation. This is the strongest possible correlation. Similarly, if your value for R is -1, this again is the strongest possible correlation. But then what's the difference? The difference is in the sign. Plus means this is positive or negative. Positive linear correlation. Minus means that this is negative linear correlation. So now read the two things together. Plus 1 is the strongest positive linear correlation. Minus 1 is the strongest negative linear correlation. Let's say your value is 0.897. This is, you could say, almost strong. It's not the strongest, but it's still strong positive. So you understand the pattern, right? The main thing you have to focus on is the magnitude, the number. The sign, don't worry about the sign. That's just telling you if it's positive correlation or negative correlation, meaning is the graph going up or is it going down? But the main thing is the magnitude. Okay. Now, how do you use your R value to complete the question? Step number 1. Make a null hypothesis. Same case. What's your null hypothesis? Your null hypothesis. So, what are you trying to find out? You're trying to find out the correlation, right? The strength of the correlation between the two variables, the x and the y. So, what's your null hypothesis? There is no significant correlation between the two variables. Simple as that. There is no significant correlation between the two variables. Step number 2, calculate the R value. We already looked at that just a minute ago. So calculate the R value. And now you know what's coming next. Step number 3, use the Pearson's table of values. You might be thinking, isn't there supposed to be an extra step, degrees of freedom? You're right, it's there. And the degrees of freedom is n minus 2. But the thing is, it's not in your syllabus. Like it's a part of Pearson's correlation, but it's no longer included in your syllabus. They had removed it around 2 to 3 years ago. So don't worry about the degrees of freedom when you're calculating or when you're solving a question about Pearson's linear correlation. So just make a null hypothesis, use the same statement every single time, calculate the R value, and then use the Pearson's table of values to do what? To reject or accept the null hypothesis. So, what's the difference between using the Pearson's table of values and, I don't know, chi-square table of values? Well, the only difference is when you're using a chi-square table of values, the column is the degrees of freedom, right? And then you're like, oh, my degrees of freedom is 3. So this is the row I have to focus on. In this case, your column right here is not going to be degrees of freedom because you didn't calculate it. It's going to be the Pearson values. Or, sorry, it's going to be the pairs of data. So, how many pairs of data did you have? You had 7 pairs of data. So, you're going to look at only the row that has 7 pairs of data. This is your main row here. And then you obviously know this is all of your p values. Let me put this up here. Oops. Let me move this up. Yeah, this is all of your p-values. So let's say 0.1 and then 0.09, 0.07, 0.05. There we go. That's our critical Pearson value. Now, if your value is greater than the critical value, you move to the right, which means that the p-value is going to be less than 0.05. So you reject the null hypothesis. I'm just going a bit fast because we have done this like 10 times now. If your Pearson value is lower than the critical value, you move to the left, which means that the p-value is going to increase. So you accept the null hypothesis that yes, there is no significant correlation between the two variables. You do the exact same thing for Spearmans. But the only thing you have to remember is what are the conditions for Spearman and what is the formula. That's the only two things that are different between Pearson and Spearman. Which two things? The criteria and the formula. The rest of the things are exactly the same. That make a null hypothesis, use the table of values, reject the null hypothesis, or accept the null hypothesis. So let's quickly look at what is the criteria for Spearman's. Think about it, right? If the data is normally distributed, what do? You use Pearson's correlation. What if the data is not normally distributed? Then you use Spearman's. So the criteria here is that the data is not normally distributed. Okay. And if the data is not normally distributed, it means, yeah, that's it. It does not mean anything. Okay, criteria number two. Just like Pearson's, you should also have at least 5 sets of values. That's simple as that, at least 5 coordinates. Number three, you need to make sure that the data is paired. What do we mean by the data is paired? The coordinates, pairs of data. So I just find this point so unnecessary. A coordinate is, of course, a pair, right? A coordinate can't be just x or just y. It's gonna be x comma y, which means that when you're talking about coordinates, automatically means you're talking about a pair. So just writing that the data is paired doesn't make sense. But again, that's an extra free mark for you guys. And number four, the data can be ranked, meaning the data is ordinal. This is not really something we have to go over, but just assume that the data can be ranked. So, for example, can you rank blood groups? Can you say the blood group A is better than O? You can't say that, right? But can you rank the heights of student in a class? Yes, you can. You can say the greatest height, you can say the smallest height, you can say the average height. You can rank the data. If the data is rankable, if it can be ranked, then you use Spearman. If it cannot be ranked, then you can't use Spearman. The formula for Spearman is already going to be provided. Don't worry about it. The values for Spearman are less than or equal to +1, more than or equal to -1. Same thing as Pearson's. +1 means strong positive correlation. -1 means strong negative correlation. Now, it's not necessary that the correlation needs to be linear. It can be non-linear as well. It doesn't matter. Plus, even if it's linear, why would you go for Spearman in the first place? If it's linear, then you go for Pearson's, right? If it's non-linear, then you go for Spearman's. So that's basically all you need to know about Pearson's and Spearman's rank correlation coefficient. Through today. Okay. सबसे पहला सवाल ये कह रहा है कि juglone is a chemical and this chemical is produced by plants in the genus Juglans. मतलब कि plants की obviously पूरा kingdom है, right? तो उसके अंदर बहुत सारी species आती हैं because we have learned King Philip came over from Greece state. एक kingdom के अंदर बहुत सारे phylum के अंदर बहुत सारे groups, बहुत सारे orders, बहुत सारे families, बहुत groups, बहुत genuses and बहुत species. तो प्लांट्स के किंगडम के अंदर जो जीनस जगलन्स हैं उससे बिलोंग करते हैं कुछ प्लांट्स जिनसे हमें जगलोन नाम का एक केमिकल मिलता है या जगलन नाम का एक केमिकल मिलता है हाउएवर यू वुड वांट टू प्रोनाउंस इट अब ये जो जीनस है राइट इट इंक्लूड्स डिफरेंट स्पीशीज ऑफ वॉलनट ट्री तो फिगर 1.1 में एक ब्लैक वॉलनट ट्री दिखाई हुई है जो केमिकल जगलन प्रोड्यूस्ड बाय अ ब्लैक वॉलनट ट्री है इट कैन डिफ्यूज इनटू द सॉइल व्हिच इज सराउंडिंग द ट्री ओके फिर उसके बाद ये लिखा हुआ है कि ग्रुप्स ऑफ साइंटिस्ट हैव ऑब्जर्व्ड कि जग लोन अफेक्ट करता है डिफरेंट स्पीशीज को प्लांट्स की डिफरेंट स्पीशीज को. सो इट अफेक्ट्स डिफरेंट स्पीशीज ऑफ प्लांट्स व्हिच आर ग्रोइंग क्लोज टू ब्लैक वॉलनट ट्रीज. डज दैट मीन कि जगलन एक हार्मफुल केमिकल है?
Yes, it is.
That's sort of what you predicted up until now, right? क्योंकि जगलन एक केमिकल है, इन्होंने अभी तक बताया, जो कि वॉलनट ट्री के प्लांट्स प्रोड्यूस करते हैं. अब फिर इन्होंने ये बताया कि जो ब्लैक वॉलनट ट्री है, उससे जो जगलन प्रोड्यूस होता है वो सॉइल में डिफ्यूज कर सकता है, ट्री के जो सराउंडिंग में सॉइल होता है. एंड एक बार वो डिफ्यूज हो जाए तो फिर अब इस ट्री के अराउंड जो छोटे छोटे प्लांट्स भी ग्रो हो रहे थे, उनकी भी डिफरेंट स्पीशीज को अफेक्ट करता है. दैट बेसिकली टेल्स अस कि जगलन एक हार्मफुल केमिकल है. एंड अगला सेंटेंस यही है, जगलन कैन रिड्यूस द परसेंटेज ऑफ सीड्स दैट जर्मिनेट. कि लेट्स सपोज पहले 70% सीड जर्मिनेट करी थी, अब लेट्स से 50% करेंगे. वी डोंट नो व्हाट द एग्जैक्ट वैल्यू इज, बट रिड्यूस कर देगा परसेंटेज ऑफ सीड्स दैट जर्मिनेट. उसी के साथ साथ जगलन डिले करता है द स्टार्ट ऑफ जर्मिनेशन और रिड्यूस ग्रोथ. कुछ स्टडीज में जगलन हैज नो इफेक्ट on the germination or growth. It's basically telling you two different studies. एक में अफेक्ट होता है, एक में नहीं होता. अब एक स्टूडेंट ने प्लान किया कि मैं इन्वेस्टिगेट करूंगा द इफेक्ट ऑफ जगलन ऑन द क्यूकम्बर प्लांट क्यूकमिस सैटिवस. और इस इन्वेस्टिगेशन में स्टूडेंट ने क्या किया, पहले तो कुछ वेट सॉइल या डैम्प सॉइल को प्लेस किया containing juglin in a tray. So what he did was he basically had a tray. उस ट्रे के अंदर he used some damp soil. Let's try to highlight it. Let's use a gray color. Yeah, soil के लिए. So he just used some damp soil. And did he put the juglin wala chemical in this damp soil?
Could you repeat?
Did he put the juglin chemical inside of this damp soil? So read the sentence again. He did, right? He just took a tray and then he put some wet soil. उसके अंदर ही उसने juglin को mix किया हुआ था, isn't it?
Yeah.
Yeah, so I'm gonna write here damn soil containing lignin. Always in the exam, try to make sure that you're drawing out stuff. If you draw out stuff, regardless of how artistic या non-artistic it is, it just makes it a bit easier to understand. अच्छा, फिर उसके बाद स्टूडेंट ने क्या किया कि कुछ क्यूकम्बर की सीड्स डाल दी सॉइल के अंदर. लेट्स यूज अ ग्रीन कलर फॉर दिस. क्यूकम्बर सीड्स ऐड कर दी टू दिस वेट सॉइल. And that basically makes sense because he's trying to see what is the effect of growth on the cucumber plant because of juggling. And फिर place the container in a suitable environment ताकि वहाँ पे germination and growth हो सके in cucumber seeds की. Any confusion अभी तक? सवाल कैसा जा रहा है? मतलब कि any part of which feels confusing?
No, it's clear.
Okay, let's move on. फिगर 1.2 shows the cucumber की सीडलिंग्स. मतलब पहले तो सीड होती है, फिर उसके बाद सीडलिंग्स बनती हैं, और फिर उसके बाद एक मैच्योर ग्रोन प्लांट बनता है. तो सीडलिंग्स आर बेसिकली जस्ट द यंग प्लांट्स अ फ्यू डेज आफ्टर जर्मिनेशन, इस तरीके के. स्टूडेंट ने फिर क्या ये बाय द वे ट्रे में सब कुछ हो रहा है जिसमें डैम सॉइल था, जिसमें जगलन था. स्टूडेंट ने क्या किया, उसने प्लान किया कि अब मैं कंपेयर करूंगा द इफेक्ट ऑफ एक्सपोजिंग दीज क्यूकम्बर सीड्स टू अ जगलन सॉल्यूशन जिसकी कंसंट्रेशन इतनी है, which is a concentration that has been measured in the soil surrounding black walnut trees. So basically जहां जहां black walnut trees grow होते हैं, उनकी सराउंडिंग्स में उन्होंने क्या किया, एक सेकेंड, उनकी सराउंडिंग्स में उन्होंने जो सॉइल था उसके अंदर जगलन की कॉन्सेंट्रेशन मेजर की. एंड दे वर लाइक कंसेंट्रेशन है इतनी, 1 × 10⁻³ मोल पर डीएम क्यूब. इतनी कंसेंट्रेशन ही जगलन सोल्यूशन इन्होंने क्यूकम्बर सीड्स में डाली. दैट्स एक्सपेरिमेंट 1. और एक्सपेरिमेंट 2 उन्होंने क्या किया, एक कंट्रोल एक्सपेरिमेंट किया. विल दिस 100% गोना बी अ क्वेश्चन रिलेटेड टू दिस लेटर ऑन. अ कंट्रोल ट्रीटमेंट, इसको हम बाद में देखते हैं. फिर स्टूडेंट ने प्लान किया कि हम डिटरमाइन करेंगे कितना परसेंटेज कितना परसेंटेज ऑफ क्यूकम्बर सीड्स ऐसी थी जिन्होंने जर्मिनेशन की सक्सेसफुली. एंड फिर जितने सीड्स ने जर्मिनेट किया, उसमें से हर सीडलिंग की ग्रोथ कितनी थी 10 days आफ्टर द अपीयरेंस ऑफ द सीडलिंग अबव द सॉइल. मतलब कि लेट्स सपोज दिस इज योर सॉइल, राइट? अब इस सॉइल में से सीड तो उसके अंदर है, सीडलिंग वो तब बनेगा जब वो सॉइल के ऊपर अपेयर होगा, राइट है। तो सीडलिंग अपेयर होने के 10 दिन बाद फिर हमने मेजर किया ग्रोथ कितनी थी। तो लेट्स से अगर सीडलिंग अपेयर हुआ 10th मई को, तो फिर 21st मई को उन्होंने ग्रोथ मेजर की। कुड यू टेल मी व्हाट्स द इंडिपेंडेंट वेरिएबल इस इन्वेस्टिगेशन में, द वेरिएबल जो हम चेंज कर रहे हैं? लुक
Uh,
एट द टू एक्सपेरिमेंट्स।
the concentration of the juglone solution.
बिल्कुल सही, द कंसेंट्रेशन ऑफ द जगलून सॉल्यूशन। एक जगह 1 × 10⁻³ मोल पर डीएम क्यूब, और एक जगह कंट्रोल एक्सपेरिमेंट हमने किया। अच्छा, कुड यू टेल मी बाय द वे, कंट्रोल एक्सपेरिमेंट का मतलब क्या होता है?
It's like basically the thing that if we change, it has, I think, no effect on the experiment.
Has no effect on the experiment. Partially true, partially true. So basically यहाँ पे हमारा इंडिपेंडेंट वेरिएबल था जगलन की कंसेंट्रेशन। कंट्रोल एक्सपेरिमेंट यहाँ पे ऐसा होगा कि हम कोई भी जगलन नहीं लेंगे। We'll take 0 mole/cm³ of जगलन। उसी तरीके से लेट्स सपोज इफ योर एक्सपेरिमेंट इज डिफ्यूजन का एक रैंडम सा एक्सपेरिमेंट लेते हैं। लेट्स सपोज यू हैव 5 ग्लास की you have 5 glasses, and then in these 5 glasses you have different temperatures of water. So एक में you have 20 degrees, एक में 40 degrees, एक में 60 degrees, एक में 80 degrees, एक में 0 degrees. What you're trying to see is that if you put the same amount of blue dye or blue ink, तो diffusion कितना होता है। ये हमारे 4 एक्सपेरिमेंट्स थे। और अब ये हमारे 5 एक्सपेरिमेंट्स है, सॉरी। कंट्रोल एक्सपेरिमेंट ऐसा होगा कि ग्लास में कोई पानी नहीं होगा। मतलब कि is diffusion gonna happen if there's no water?
No, it won't.
It won't. That is the definition of a control experiment. तो फिर you might be thinking, right, अगर पानी ही नहीं है तो फिर कंट्रोल एक्सपेरिमेंट का फायदा क्या है? It's basically just to show कि पानी होने से क्या फर्क पड़ता है। जब हमने पानी नहीं डाला तो कोई डिफ्यूजन नहीं हुई। मतलब कि पानी डालने का फायदा ये था कि डिफ्यूजन हमें देखने को मिली। So basically a control experiment is just for you to be able to compare comparison with this and this. That's the benefit of a control. अगर हम कंट्रोल एक्सपेरिमेंट नहीं रखते तो फिर हम ये भी कह सकते थे कि पानी नहीं भी होता फिर भी डिफ्यूजन हो जाती, तो फिर पानी रखने की जरूरत क्या थी। सो दैट्स व्हाई वी यूज अ कंट्रोल एक्सपेरिमेंट। अच्छा, जगलन सॉल्यूशंस फिर प्रिपेयर किए गए एक मिक्सचर ऑफ सॉल्वेंट। सो दिस इज अ क्लासिकल डाइल्यूशन का क्वेश्चन, समथिंग यू माइट हैव डन योर लैब्स P3 में, proportional dilution, simple dilution. Let's see. So juggling solutions are prepared using a mixture of solvents. The student was provided with a juglone solution, और इस जुगलन सॉल्यूशन की कंसेंट्रेशन बताई हुई है 0.1 मोल पर डीएम क्यूब, और फिर वो मिक्सचर ऑफ सॉल्वेंट्स भी प्रोवाइड किए हुए थे। यूजिंग दिस सॉल्यूशन जो प्रोवाइड किया था जगलन का, स्टूडेंट ने एक ऐसा सॉल्यूशन प्रिपेयर किया जिसकी वॉल्यूम थी 500 क्यूबिक सेंटीमीटर, और कंसेंट्रेशन इसकी थी 1 × 10⁻³ ऑलवेज इन द एग्जाम। आई कैन यू यूज अ हाइलाइटर बाय द वे एग्जाम में? आई एम नॉट श्योर, आई डोंट रिमेंबर।
Uh, no, I haven't really used it. I think we're not supposed to use anything but like pencil and pens, I think.
So in that case, just use a black pen, blue pen, pencil, but make sure to highlight वो parts जिनमें numbers लिखे हों, so that whenever you go back to the question, अब हमें search नहीं करना पड़ेगा number वाला हिस्सा कहाँ पे था, it's already highlighted for us. तो जो solution बनाया था उसकी volume थी 500 cm³ and concentration थी 1 × 10⁻³ मोल पर डेसीमीटर क्यूब। स्टूडेंट ने क्या किया, इस सॉल्यूशन को बनाने के बाद एक डाइल्यूशन किया। डाइल्यूशन का मतलब क्या होता है कि किसी भी ऑलरेडी बनाए हुए सॉल्यूशन में थोड़ा सा पानी और ऐड कर देना, ताकि हम उसको डाइल्यूट कर सकें, कंसेंट्रेशन ऑफ सॉल्यूट को कम कर सकें। सो कैरीड आउट वन डाइल्यूशन टू प्रिपेयर द 1 × 10⁻³ मोल पर डेसीमीटर क्यूब सॉल्यूशन यूजिंग मेजरिंग सिलेंडर्स। तो बेसिकली अच्छा, इट्स टेलिंग अस कि ये सॉल्यूशन बनाने के लिए डाइल्यूशन की उसने। स्टेट द वॉल्यूम्स दैट द स्टूडेंट यूज्ड डाइल्यूशन करने के लिए, ताकि ये वाला सॉल्यूशन बन जाए। सो व्हाट वर द वॉल्यूम्स? यू हैव टू टेल इट सेपरेटली, एज इन कि जगलन की कितनी वॉल्यूम थी एंड देन वो मिक्सचर ऑफ सॉल्वेंट्स जो था उसकी कितनी वॉल्यूम थी। So think about it. Try to apply a formula which you might have used in P3.
Just give me a second. I'll just trying to write it down.
Yeah, sure, sure. Take your time.
Will we use C1 V1 equals to C2 V2?
बिल्कुल सही. कभी भी dilution का question हो, that's the only formula which you need to remember. So in that case, what's the answer here?
Is it like 5% of the like the original solution and then like the I think 495 of the like other solvent, the mixture
Hmm.
solvent?
बिल्कुल सही. अच्छा, percentage या CM cubed? क्योंकि व्हेन यू टॉक अबाउट
Centimeter
C1
cube?
V1, या बिल्कुल सही, सेंटीमीटर क्यूब. क्योंकि जब हम वॉल्यूम की बात करें, राइट, सो वॉल्यूम तो परसेंटेज में यू कैन गिव इट, बट दैट्स व्हेन यू इनिशियली गेट इट इन सीएम क्यूब एंड देन यू कन्वर्ट इट टू अ परसेंटेज. हमें वो कन्वर्जन करने की जरूरत ही नहीं है. हमें डायरेक्ट वॉल्यूम्स में आंसर लिखना है. सो यू राइट. जब हम करेंगे C1 V1 इक्वल्स C2 V2, सो कुड यू टेल मी हाउ विल यू सॉल्व दिस, मतलब हाउ विल यू यूज दिस फॉर्मूला, as in what's C1 V1, what is C2 V2?
Okay, so basically the original concentration is 0.1
Mhm.
and yeah, I mean the first concentration. And basically this constant the second concentration is 1.0 into 10 to the power minus 3. And
Correct, because this is the concentration that we want to make. बिल्कुल सही.
yeah,
Yeah, after that,
and basically the volume is the V1 volume, it's like 500.
the okay, let's try. The V1 volume is 500. Okay, फिर. And then you're saying the V2 is going to be X.
Mm.
So in that case, is X, what's the value of X coming out to be as?
No, no, no. I think a second. It was I think
Actually, it is the other way around. The
yeah. I just
V1,
realized. Sorry.
yeah, the V1 is always the X. And we could also think of it like this. V1 का मतलब था कि जो जगलन सॉल्यूशन था जिसकी कंसंट्रेशन हमने C1 लिखी थी, तो हम असल में तो यही पता करना चाह रहे हैं, राइट, कि इस जगलन सॉल्यूशन में से हमें कितनी वॉल्यूम यूज करनी है. दैट्स आर अननोन. सो जगलन सॉल्यूशन जिसकी C1 कंसंट्रेशन है, आर अननोन वॉल्यूम इज V1. एंड फिर V2 इज ऑब्वियसली जो सॉल्यूशन हमें बनाना है टोटल में, एंड दैट इज बेसिकली जस्ट 500. सो फिर व्हाट वैल्यू डज X कम आउट टू बी एज? You said 5, right?
Yeah.
या सो 5 क्यूबिक सेंटीमीटर ऑफ जगलन सॉल्यूशन. और फिर जो हमारा V2 था उसमें से सिर्फ x को हम माइनस कर देंगे. दैट्स 500 माइनस 5, एंड यू राइट, दिस इज 495 क्यूबिक सेंटीमीटर ऑफ द mixture of solvents. So you could just write the solvents. It's the same thing. Outline one improvement. हमें एक improvement बतानी है which the student could make to reduce the percentage error while carrying out the dilution. So what do you think? So what's percentage error, by the way? You must have learned this in physics. Percentage error क्या होता है?
Like the percentage of the error, I think in the apparatus.
Yes, so percentage error basically is just absolute uncertainty जिसको हमने एक percentage में convert कर दिया. That's just percentage error. तो एब्सोल्यूट अनसर्टेनिटी जो होती है वो इंस्ट्रूमेंट यूज करते वक्त आती है. सो यहाँ पे व्हाट डू यू थिंक इज द इम्प्रूवमेंट टू रिड्यूस द एब्सोल्यूट अनसर्टेनिटी और रिड्यूस द परसेंटेज एरर?
Could we like use larger volumes of the solutions?
दैट्स अ गुड आइडिया, बिल्कुल सही, करेक्ट. What about the and that's one mark. बिल्कुल सही, you got the one mark. But what about the apparatus? How can we change the apparatus?
We could like use a more accurate apparatus, like for example, we could use maybe a burette or something.
अब ब्यूरेट, बिल्कुल सही, हम ब्यूरेट यूज कर सकते हैं. हम ऐसा पिपेट यूज कर सकते हैं जिसके ऊपर ग्रेजुएशंस बनी हुई हो. दैट्स बेसिकली कॉल्ड अ ग्रेजुएटेड पिपेट. Something you must have learned in chemistry. So graduated pipette use कर सकते हैं, या Bure is also a better idea. But again, your first idea was बिल्कुल सही, using larger volumes. क्योंकि जब हम volumes ज़्यादा use करते हैं, remember how do you calculate absolute uncertainty? You have the uncertainty divide by the actual value multiplied by the value, the percentage.
Yeah.
सो दिस एक्चुअल वैल्यू, जितना ज्यादा हम उसको बड़ा लेंगे, जितना ज्यादा डिनोमिनेटर बड़ा होगा, उतनी ज्यादा एब्सोल्यूट अनसर्टेनिटी छोटी होगी, एंड उतना ही छोटा हमारा परसेंटेज एरर होगा. सो बेसिकली ऑल यू डूइंग इज इंक्रीजिंग द डिनोमिनेटर वैल्यू, इन अदर वर्ड्स यूजिंग ग्रेटर values or volumes of both the juggling solution and the mixture of solvents. Let's use the blue color यहाँ भी. Using greater volumes of both the juglone solution and the mixture of solvents. Okay, now state a suitable control. एक ऐसा control experiment that the student could use, and explain why the student decided to include a control in the investigation. तो remember उन्होंने शुरू में हमें बताया था कि एक control treatment use किया गया, but they didn't actually tell us what that treatment was, and that's why they're asking us this now. What do you think should be the control experiment?
Like we could use a mixture of like the other solvents. I think they were solvents. Yeah.
Yeah, solvents. Yeah.
So we could like use like that mixture, and but we won't add juglone to that.
बिल्कुल सही. एंड दैट्स द सिंपल ट्रिक दैट यू शुड यूज जब भी वो कंट्रोल एक्सपेरिमेंट पूछे. ऑल यू नीड टू नो इज हमारा इंडिपेंडेंट वेरिएबल क्या है. हमारा इंडिपेंडेंट वेरिएबल था कंसंट्रेशन ऑफ जगलोन, कि हम कभी 5 ले रहे हैं, कभी 10 ले रहे हैं, कभी 5 सेंटीमीटर, कभी 10 सेंटीमीटर. तो कंट्रोल एक्सपेरिमेंट कभी भी ऐसा एक्सपेरिमेंट होता है जहां इंडिपेंडेंट वेरिएबल मौजूद ही ना हो. राइट दिस है, कंट्रोल एक्सपेरिमेंट is an experiment where the independent variable is not present. So remember हमने एक एग्जांपल अभी भी किया था जब हम टेम्परेचर्स ऑफ वाटर देख रहे थे. सो डिफरेंट टेम्परेचर्स ऑफ वाटर, इन दिस केस क्या टेम्परेचर ऑफ वाटर हमारा इंडिपेंडेंट वेरिएबल है?
No,
So what's going to be our independent variable, as in what are we changing from container to container?
the concentration of juglone.
नहीं नहीं, नॉट इन आवर क्वेश्चन. ये जो एग्जांपल हमने किया था जहाँ टेम्परेचर ऑफ वाटर को हम देख रहे थे, एक को 20
Oh
डिग्रीज, एक
yeah,
को
then we
4
were changing the temperature.
द टेम्परेचर. तो कंट्रोल एक्सपेरिमेंट या कंट्रोल सोल्यूशन हमारा ऐसा होगा जिसमें कोई पानी ही ना हो, ताकि कोई टेम्परेचर जो इंडिपेंडेंट वेरिएबल था उसकी कोई बात ही ना हो. तो इसलिए वी सेड कि नो वाटर एंड ओनली द ब्लू डाई इज गोना बी आवर कंट्रोल एक्सपेरिमेंट. सो कंट्रोल एक्सपेरिमेंट इज एन एक्सपेरिमेंट वेयर द इंडिपेंडेंट वेरिएबल इज नॉट प्रेजेंट. सो यू आर राइट, एक ऐसा हमें सोल्यूशन बनाना है विथ नो जगलोन प्रेजेंट. बट अभी भी मेन सवाल है, कंट्रोल एक्सपेरिमेंट करा क्यों जाता है? That's part two of this question. What do you think?
Like we want to like observe whether it like for example the concentrated juglone, we want to see if like it has an effect on like the whole experiment maybe.
बिल्कुल सही, but could you specify आखिरी वाला part, the whole experiment, as in
Like for
जग
example
लोन का?
the germination over here, like we are looking at the germination, right?
बिल्कुल सही, yeah. Yeah, you're right. Affected germination हो सकता है, और कोई other effect you could think of किस पर?
On the
मतलब कि, yeah,
growth of the plants.
the growth of the seeds, right? क्योंकि seeds से हम शुरू कर रहे थे,
Yeah.
and seeds को ही हमने soil में रखा था और जगलून भी soil में होता है, so seeds. And yeah, बिल्कुल सही. Just to see कि कोई effect होता भी है या नहीं होता है जगलून का on the germination या slash or the growth of seeds. You could use any. So to see if there is any effect of jugloon on the, we'll use your first answer, germination of seeds. So that's our 2 marks right there. Actually, let's move on. Now here's the main part of P5, a 7 mark question. So think about it, take your time, draft your entire answer, and then let me know. The question क्या है? Describe a method, मतलब अभी तक हमने समझा नहीं है क्वेश्चन एक्चुअली हमसे पूछ क्या रहा है. Describe a method the student could use to investigate the effect of juglone on the percentage of cucumber seeds that germinate. तो बेसिकली स्टूडेंट ये देखना चाह रहा है कि जगलोन का क्या असर पड़ता है ऑन द परसेंटेज ऑफ द सीड्स जो जर्मिनेट कर रहे हैं. मतलब जगलोन ज्यादा हो तो क्या कम परसेंटेज जर्मिनेट करती है, या जगलोन ज्यादा हो तो ज्यादा परसेंटेज जर्मिनेट करती है. दैट्स बेसिकली द इफेक्ट. एंड फिर सिर्फ परसेंटेज ऑफ सीड्स दैट जर्मिनेट एक इफेक्ट नहीं है जो हमें देखना है. हमें ये भी देखना है कि जगलोन की वजह से ग्रोथ पे क्या फर्क पड़ता है ऑन द क्यूकर ऑन ईच क्यूकम्बर सीडलिंग 10 days after the appearance of the seedlings above the soil. So the description of your method, ये तो हर P5 में same होता है. The description of your method should be set out in a logical way and be detailed enough for another person to follow it. So ignore this, just focus on this. 7 marks, so 7 points. Once you give me your answer, I'm gonna give you a template you can follow. Maybe you already have that. And those templates, so you can just use it to for answer every single P5 answer. So just try this first. And let me know when you're done.
There have they written any hazard in the question about juglone or something?
No. So you might have to figure that out yourselves if you feel okay, writing the hazard could be a point in your answer.
Okay.
Yeah.
Yeah, so I've written down the points.
Okay. Have you written them down on paper? If you could just send it, or you could just read it out loud. It's fine.
Yeah, I'll just read it out. So,
Okay.
like, basically, so first of all, we can state the independent variable and like the dependent variable. So, like, the independent variable is going to be the concentration of juglone, and basically, the dependent variable is going to be the percentage of the cucumber seeds that germinate.
Okay.
And then basically for the controlled variables, they could be the temperature and the amount of light, so like basically the light intensity. And I think the type and like the type of seeds maybe, or like the size of them. And like how we can control all of these for like temperature. Um, for temperature, I think we could use like somewhat like a maybe like a heat shield or something.
Okay.
And like for the intensity, we could like use like maybe a lamp with like the same like voltage, yeah, the same voltage. And then maybe for the type and size of seeds, we could like use like roughly the same size of and type of seeds we're using.
Okay.
uh,
But isn't that like just explaining the control variable again? Okay, using the same type of seed, and then how
okay.
do we keep it same using the same type? So वो repetition हो जाएगी. Okay. Yeah. Ignore this point and just move on. I'll put
Okay.
a slash. Yeah.
Yeah, okay. And then basically we could like so at like different concentrations of juglone in like the soil, we could then like leave it like for the 10 days, and then we could m- like record like the number of seeds that germinated like after a specific time. And like at set intervals maybe, and like we could
Set intervals. You said 10 days, but per set intervals फिर हम कैसे इसमें include करेंगे?
like could we like measure it like after maybe 2 days, 4 days, and 6 days, and 8 days,
Oh,
something
like
like.
that. Okay, makes sense. सही है.
Yeah, and then basically we could so and then like we could after like the after 10 days, like so basically we could measure it again, and then we can like calculate like the number of seeds that have germinated, and then we could calculate the mean. And also we could repeat the again, sorry, I'm repeating the point, but like I think this is better. Like we could repeat
Mhm.
like the experiment at least like thrice, and then calculate a mean to remove the anomalies, I think. Yeah.
Yeah,
And
yeah.
then basically for I think I've also written risks. So like basically the juglone solution and the solvents, they could be irritants. So like we could wear gloves for that. And
Mhm.
yeah, so it's like a mid risk. It's mid-risk, or I think low risk experiment, something like that we call it. Yeah,
Okay.
that's it, I think.
Okay. तो यहाँ पे let's first mark it together कि कौन से points you wrote down and the marks you got for what point. तो independent variable concentration of drug load, that's one mark for that. फिर उसके बाद concentration of, let me just read through your entire answer again. Okay. Okay, yeah. Independent variable and dependent variable. बिल्कुल सही. अच्छा, independent, and we're gonna talk about this more in the template after this. Independent and dependent carry 1 mark, so that's good. Control variable you mentioned 3, which is more than enough. बिल्कुल सही. That's 1 mark right there. एक control variables को constant कैसे रखना है? Perfect. That's another mark there. फिर थोड़ी बहुत प्रोसेस की बात, तो ये प्रोसेस की बात हमने कर ली. Another mark there. फिर हमने concentrations को सॉरी जो परसेंटेज ऑफ सीड्स जो जर्मिनेट करती हैं उनको हमने मीन उनका निकालना है एंड देन मेजर करना है 10 डेज विद इंटरवल्स, दैट्स अनदर मार्क फॉर दैट. एंड देन रिपीट वाला जो पॉइंट आता है ताकि हम एनोमलीज हटा सकें, अनदर मार्क फॉर दैट. एंड हैजर्ड्स वाला का एक और मार्क. सो दैट्स 1 2 3 4 5 6 and 7. सो राइट ऑन द डॉट 7 out of 7. अब यहाँ पे आई एम गोना गिव यू अ टेम्पलेट which you could follow. But again, completely up to you. If you might have another template in your mind, your teacher would have given you anything which makes your answer a bit more better. But let's see. Whenever you attempt a P5 bio ka question, now don't link it with physics and chemistry. Different templates for different subjects. Bio ke liye, the template you need to follow is your first line needs to be about what's the independent variable प्लस हमारा जो डिपेंडेंट वेरिएबल है वो कौन सा है. सो कौन सी वेरिएबल हम चेंज कर रहे हैं एंड कौन सा वेरिएबल हम मेजर कर रहे हैं एज अ रिजल्ट ऑफ दैट चेंज. दैट्स लाइन नंबर वन. अगेन मैं ये नहीं कहने वाला लाइन टू लाइन थ्री लाइन फोर ये नहीं चाहिए, बट योर फर्स्ट 3 या 4 पॉइंट्स में से सबसे पहला ये होना चाहिए. पॉइंट नंबर टू, व्हाट आर योर कंट्रोल वेरिएबल्स. Control variables में you can mention two or a maximum of three. I would not advise going more than that because then फिर हम सिर्फ lines use up कर रहे होते हैं and we are not getting extra marks for it. So two या maximum three. If you feel कि two बेहतर है, मतलब कि two अच्छे points है और एक थोड़ा medium सा point है, इतना खास नहीं है, so just put two. But if you feel 3 points are good, then just put three in this case, three in that case. तो तीन control variables आ गए. अगला point, इंडिपेंडेंट वेरिएबल. हम उस वेरिएबल को कहते हैं राइट जो हम चेंज कर रहे हैं. हाउ टू चेंज द इंडिपेंडेंट वेरिएबल. सो फॉर एग्जांपल, हाउ विल यू चेंज द जगलन कंसंट्रेशन हियर. सो एज इन हाउ आर यू गोना क्रिएट डिफरेंट डिफरेंट कंसंट्रेशंस ऑफ जगलोन ताकि हम उसको इंडिपेंडेंट वेरिएबल की तरह ट्रीट कर सकें.
Like we're going to like maybe dilute it.
डाइल्यूटेड, बिल्कुल सही. एंड दैट पॉइंट कैरी द मार्क कि इंडिपेंडेंट वेरिएबल को चेंज कैसे किया जाता है. एनी नाउ इफ यू जस्ट इंक्लूड द वर्ड डाइल्यूशन, दैट्स परफेक्ट, दैट्स अ मार्क राइट देयर. कि हम डाइल्यूशन, नाउ यू कुड इवन से हम प्रोपोर्शनल डाइल्यूशन यूज करेंगे, हम सीरियल डाइल्यूशन यूज करेंगे. अब इतना हमें डिटेल में भी नहीं जाना, जस्ट राइट प्रोपोर्शनल डाइल्यूशन C1V1 इक्वल्स C2V2, दैट इज इट. दैट्स हाउ वी कैन चेंज द इंडिपेंडेंट वेरिएबल. फिर पॉइंट नंबर टू, हाउ टू चेंज द डिपेंडेंट वेरिएबल. जिस वेरिएबल, सॉरी, हाउ टू मेजर, जिस वेरिएबल को हम मेजर कर रहे हैं उसको हम एक्चुअली में मेजर कैसे करेंगे. सो फॉर एग्जांपल, वन यहाँ पे इस एक्सपेरिमेंट में कितने डिपेंडेंट वेरिएबल्स थे. There were two dependent variables, right? Percentage of cucumber seeds that germinate and then growth after 10 days of the seedlings above the soil.
Yeah.
Now, how are you going to measure the growth of the seedlings 10 days after the appearance of the seedlings above the soil? हम एक मेजरिंग स्केल यूज कर सकते हैं कि कितनी उनकी वर्टिकल हाइट में ग्रोथ आया. हम उनका मास मेजर कर सकते हैं, बट फॉर मास यू नीड टू प्लक इट आउट, सो वी कांट रियली मेजर दैट. बट या यू कैन मेजर द लेंथ. फिर उसके बाद परसेंटेज कैसे मेजर करेंगे कि यू कैन इवन टेल, इफ यू थिंक कि कोई पॉइंट बहुत बेसिक है, उसको लिखने का कोई पॉइंट नहीं है, दोज आर द पॉइंट्स दैट कैरी द मार्क्स इन ये वाला जो P5 का मेन सवाल होता है. तो इसमें यू कैन से कि इफ यू टेक द नंबर ऑफ सीड्स दैट जर्मिनेट डिवाइड बाय टोटल नंबर ऑफ सीड्स मल्टीप्लाई बाय 100, फॉर्मूला का एक मार्क होता है. सो हाउ टू मेजर द डिपेंडेंट वेरिएबल. पॉइंट नंबर थ्री, how to control the control variable, which is good. I appreciate you mentioned the points here कि जो जैसे टेम्परेचर है उसके लिए हीट शील्ड यूज करेंगे, लाइट इंटेंसिटी के लिए एक लैम्प जिसकी वोल्टेज सेम है. टाइप ऑफ सीड के लिए हमें क्या करना चाहिए. जरूरी नहीं है कि जितने भी कंट्रोल वेरिएबल्स हम लिस्ट करें हर किसी का हम तरीका लिखें. नो, if you mention three control variables, mention the ways to control two of them. That's it. कोई जरूरत नहीं है मैं तीनों को मेंशन करने की, क्योंकि फॉर एग्जांपल हियर यू डिडंट रियली नो हाउ टू कीप द सेम टाइप ऑफ सीड, राइट. अब इसका हो सकता है मेथड कि यूज द सेम पैकेट ऑफ सीड्स व्हिच यू आर ओपनिंग, ताकि यू जो मास है सीड्स का एंड जो टाइप है वो ऑलमोस्ट सिमिलर हो. लेकिन ये पॉइंट्स हमें एग्जाम सिचुएशन में आते नहीं है, राइट. सो जस्ट इग्नोर दिस, जस्ट मेंशन दीज टू. सो हाउ टू कंट्रोल द कंट्रोल वेरिएबल्स. अच्छा, उसके बाद थोड़ी बहुत हम बात करेंगे, इनफैक्ट सॉरी ज्यादातर बात हम प्रोसेस की करेंगे. प्रोसेस कैसे काम करेगा, विच इज गुड, यू ऑल्सो मेंशन्ड दिस. फिर उसके बाद दो फ्री के मार्क्स फॉर एवरी सिंगल P5 क्वेश्चन इज रिपीट वाला पॉइंट. Every experiment, you're gonna repeat it. So you're gonna say repeat at least twice. You can mention the same sentence if you want. Repeat at least twice to avoid anomalous results, as you said. Anomalous results या anomalies को avoid करने के लिए. And एक और चीज भी also you could add, repeat at least twice and then take average. क्योंकि repeat करने का फायदा नहीं, right, अगर हम average ना निकाल रहे हो. So repeat twice and at least twice and then take average to avoid anomalous results. And अगला point, hazards, risk and precaution. अब इन तीन चीजों के बीच में हम डिफरेंस समझते हैं. Hazard versus risk versus precaution. Precaution का मतलब is simple, right? Precaution just means कि हम क्या safety equipment यूज कर रहे हैं, gloves, mask, PPE की kit यूज कर रहे हैं. But could you tell me the difference between a hazard and the risk? इसमें फर्क क्या होता है?
I think hazard is like, for example, the chemicals they are hazardous, like they can be irritants and stuff. And like for risk, I think it's still like possible to prevent it, though hazards can be prevented when you take precautions.
I get what you're trying to say, but it's not really that. Hazard और risk में ये वाला फर्क नहीं है कि hazard ज़्यादा dangerous होता है, risk कम dangerous होता है, not really. रिस्क इज बेसिकली द चीजें जो हमें होती हैं, जैसे कि इरिटेशन हो, एलर्जी हो, फिर उसके बाद डेथ भी हो सकती है. कुछ अब बायो का एक्सपेरिमेंट, उसमें डेथ नहीं हो सकती है, बट कुछ फिजिक्स के एक्सपेरिमेंट्स में बहुत ज्यादा इलेक्ट्रिसिटी की वैल्यूज यूज हुई है, तो इलेक्ट्रिक्यूशन से डेथ भी हो सकती है. दैट्स अ वेरी वेरी हाई रिस्क. तो रिस्क यहाँ पे हम लिखेंगे कि क्या क्या चीजें हमें हो सकती हैं. हैजर्ड्स वो चीजें हैं जिनकी वजह से रिस्क हो सकता है. सो फॉर एग्जांपल, यहाँ पे सॉल्वेंट्स हो गए, फिर उसके बाद जग लोन हो गया, जग लोन, फिर उसके बाद सॉइल हो गया, उसके बाद क्यूकम्बर की सीड्स हो गई. ये सारी चीजें हमारे एक्सपेरिमेंट में कोई अपना अपना रोल प्ले करती हैं, और इन सब की वजह से कोई ना कोई रिस्क है. फॉर एग्जांपल, क्यूकम्बर सीड से कुछ लोगों को एलर्जी होती है, दैट्स वियर्ड, बट या दैट्स अ रिस्क. जगलन की वजह से कुछ लोगों को इरिटेशन होती है, दैट्स अनदर रिस्क. सॉइल की वजह से उस सॉइल के अंदर कुछ पैथोजेंस हो सकते हैं, जिसकी वजह से अगेन दे माइट हार्म अस, दैट्स अ रिस्क. इनके लिए प्रिकॉशंस क्या ले सकते हैं? इनके लिए हम ग्लव्स यूज कर सकते हैं, एज यू सेड. इनके लिए हम मास्क यूज कर सकते हैं. इनके लिए हम पीपीई किट यूज कर सकते हैं. बायो के क्वेश्चंस में मोस्टली द प्रिकॉशन इज दीस थ्री: ग्लव, मास्क, पीपीई किट, एंड देयर इज आल्सो अनदर वन, आई वेयर. दैट्स इट. It's only one out of these four, or two out of these four. So that's basically all of the points you can include. जिसमें से एक, दो, तीन, चार, पाँच, छः, सात, आठ, एंड देन फिर ये जो हाउ टू कंट्रोल, मेजर एंड चेंज है, इनके एक्स्ट्रा एक्स्ट्रा मार्क्स हैं इफ यू कीप राइटिंग मोर पॉइंट्स. तो अब 7 मार्क का हो, 8 का हो, 9 का हो, 10 का हो, कभी कभार 12 मार्क का भी आता है. सो यू कैन आंसर दिस. एनी कंफ्यूजन इस पूरे टेम्पलेट में?
No, it's clear.
Okay. If you want to take a screenshot, or I can just send you the document later. I think
Yeah,
that
you
would
can
be,
send me the document.
yeah. Okay, let's move on. अनदर स्टूडेंट ने क्या किया, इन्वेस्टिगेट किया जगलोन का इफेक्ट, लेकिन इस बार ऑन अ डिफरेंट स्पीशीज ऑफ प्लांट. मतलब अब क्यूकम्बर सीड्स के साथ वो नहीं कर रहा, और अ डिफरेंट स्पीशीज कॉल्ड क्रिम्सन क्लोवर. इसका जो बाइनोमियल नेमिंग सिस्टम में नाम है वो है ट्राइफोलियम इनकार्नेटम. स्टूडेंट ने रिकॉर्ड किया द नंबर ऑफ डेज, कितने दिन लगते हैं जर्मिनेशन में. किस चीज की जर्मिनेशन में? पहले तो 10 सीड्स जिनको ट्रीट किया जाए जगलन सोल्यूशन जिसकी कंसेंट्रेशन इतनी है, और फिर ये भी देखा कि कितने दिन लगते हैं ऐसे 10 सीड्स की जर्मिनेशन जिनको जगलन के साथ ट्रीट नहीं किया जाए. The student used the t-test to analyze the results. The student used the t-test to analyze the results. The t-test is appropriate for the number of seeds that were used. Suggest two other reasons why the t-test is an appropriate statistical test to use for this investigation. मतलब कि हम chi squared या हार्डी वाइनबर्ग इक्वेशन हम सिर्फ क्यों नहीं यूज करते, हम सिर्फ टी टेस्ट क्यों यूज करते हैं?
Could you repeat?
I'm just asking you the answer ये question का. Why do you think the T test is an appropriate test to use? हम दूसरे test क्यों नहीं use करते यहाँ पे?
Because
Basically the
data,
question here.
it's like normally distributed and it's also continuous.
बिल्कुल सही. The data is normally distributed and it is also continuous. बिल्कुल सही. So basically जैसे हमने पढ़ा था पियर्सन एंड स्पेयरमैन का एक क्राइटेरिया होता है कि अगर क्राइटेरिया में फिट बैठता है डेटा तभी हम पियर्सन यूज करेंगे या स्पेयरमैन यूज करेंगे. सेम चीज टी टेस्ट के लिए भी होती है, क्राइटेरिया होता है. एंड यू आर राइट, उनमें से दो पॉइंट्स ये हैं कि नॉर्मली डिस्ट्रीब्यूटेड डेटा एंड कंटिन्यूअस डेटा होना चाहिए. ओके, लेट्स मूव. द नल हाइपोथेसिस, we know what null hypothesis is. For the t-test was there is no difference. That's what a null hypothesis is. There is no difference between the time taken for the seeds to germinate when treated with juglone and the time taken for seeds to germinate when not treated with juglone. Basically वो कहना चाह रहे हैं कि juglone का कोई effect होता ही नहीं है. That's the null hypothesis. टी वैल्यू जो कैलकुलेट की वो थी 2.09. स्टूडेंट ने कंपेयर किया 2.09 टू द वैल्यूज इन टेबल 1.1. एग्जैक्टली द सेम चीज जो हमने पियर्सन एक्सपेरिमेंट में पढ़ी है, p इक्वल 0.05 वाला टॉपिक. एग्जैक्टली सेम चीज. यूजिंग टेबल 1.1 एंड द कैलकुलेटेड वैल्यू ऑफ 2.09, स्टेट एंड एक्सप्लेन व्हाट द स्टूडेंट कैन कंक्लूड. सो हमारी वैल्यू है 2.09. What is our critical value of t right here?
It's
मतलब इनमें से. Yep.
it's the at like it's 2 point uh
It's gonna be one of these five values क्योंकि p equals 0.05 पे critical value थी. But which one? कौन सी degree of freedom हम लेंगे?
19.
Actually t test के लिए degree of freedom होता है n-2. तो यहाँ पे हमारे पास total 20 टेस्ट थे. तो 20 - 2 is gonna be 18. तो 18 इज द, क्योंकि n का मतलब होता है बेसिकली नंबर ऑफ पेयर्स ऑफ डेटा, राइट? तो हमारे पास उस पेयर में क्या डेटा है कि जगलोन का नंबर कौन सा था, मतलब वाज इट द फोर्थ जगलोन, द फिफ्थ वन और द सिक्स्थ वन, एंड फिर उसकी ग्रोथ कितनी थी. दैट्स आवर कोऑर्डिनेट. तो n-2 इज 18. दिस राइट हियर इज आवर क्रिटिकल वैल्यू. अगेन नो प्रॉब्लम, इवन इफ यू डोंट रिमेंबर दिस, हम टी टेस्ट जब करेंगे तो उसको रिवाइज कर लेंगे हम. अच्छा, now look at your calculated value and look at your critical value. Is your calculated value lesser or greater compared to critical value?
Lesser
Meaning you would have to go to the left or to the right.
to the left.
बिल्कुल सही. And when you're going to the left, क्या p की वैल्यू इंक्रीज हो रही है, डिक्रीज हो रही है? 0.05 and 0.1, is it increasing or decreasing?
Increasing.
It is increasing. बिल्कुल सही. So the point number one is going to be for this question. It's a 3 mark question. The calculated value जो t की है is lesser than the critical value of t at p is equal to 0.05. This means that p value is going to be more than 0.05. And in that case, do we reject the null hypothesis or do we accept it?
We are going to accept the null hypothesis because there is
We are,
no significant difference.
sorry, could you repeat?
We are going to accept the null hypothesis because there is no significant difference.
बिल्कुल सही. We are going to accept the null hypothesis. And you're right. आखिरी चीज में रिमेंबर हमने बात की थी कि null hypothesis के बाद भी हमें context देना है. हमें generally नहीं लिख देना है कि we accept the null hypothesis and there is a significant difference. ऐसे नहीं. We need to give it some context according to our question. So we accept the null hypothesis that there is no significant difference between what two things?
Could you move a bit? Yeah. So like there's no significant difference between the time taken for the seeds to germinate with juglone and the for the seeds to germinate when not treated with juglone.
बिल्कुल. Always make sure to write the context after writing down कि if you accept or reject the null hypothesis. मतलब कि after writing down कि अगर कोई significant difference होगा या नहीं होगा. So between the time taken for seeds to germinate when they are treated. I'm going below the line, but please make sure in your exam you do not go below the line क्योंकि वो scan करते हैं आंसर को and आंसर जब scan होता है तो फिर वो below the line मार्क नहीं कर पाता. When they are treated with juglone versus when they are. Okay, let's move on. Compounds containing nitrite ions are present in many foods which is eaten by humans. Now, nitrite ions and nitrate ions में often एक confusion आता है. And that is when we talk about the word nitrate, इसका मतलब होता है NO3 minus. And then when you talk about the word nitrite, that is basically NO2 minus. So just make sure of that. And यहाँ पे obviously उन्होंने लिखा हुआ भी है कि ये NO2 minus है nitrite ions. तो ये बता रहे हैं कि ऐसे कंपाउंड जिनमें ये वाला आयन होता है, ये ऐसे बहुत से फूड्स में मौजूद होता है which is eaten by humans. साइंटिस्ट ने क्या किया, इन्होंने टेस्ट किया दी अफेक्ट किस चीज का ऑफ डिफरेंट कंसेंट्रेशंस ऑफ नाइट्राइट आयंस ऑन द पॉपुलेशन की ग्रोथ ऑफ 5 स्पीशीज ऑफ बैक्टीरियम. मतलब उनको देखना था कि कितना ज्यादा परसेंटेज ग्रोथ हो रहा है या पॉपुलेशन का ग्रोथ हो रहा है अलग अलग बैक्टीरिया की ही स्पीशीज पे जब उनको डिफरेंट डिफरेंट नाइट्राइट आयंस की कंसेंट्रेशन से एक्सपोज किया जाए. All 5 species are pathogenic and can infect the human digestive system. The word pathogens, you must have learned this in AS. Pathogens का मतलब होता है ऐसे substances जो कि immune system को infect और damage करने के लिए होते हैं. For example, cholera, Vibrio cholerae की वजह से होता है. Vibrio cholerae is a pathogenic bacteria. Mycobacterium tuberculosis, that's a pathogenic ऑर्गेनिज्म जो कि ट्यूबरक्लोसिस कॉज करता है. HIV, इट्स अ पैथोजेनिक वायरस जो कि एड्स कॉज करता है. सारे के सारे पैथोजन हैं. अच्छा, अब देखते हैं. फॉर ईच स्पीशीज ऑफ बैक्टीरियम साइंटिस्ट ने क्या किया कि सस्पेंशन प्लेस की बैक्टीरिया की एक माइक्रोवेल प्लेट के अंदर. सो थिंक ऑफ इट एज अ पेट्री डिश का प्लेट सिमिलर टू दैट. उसमें सस्पेंशन डाल दी ऑफ द बैक्टीरिया. सो 5 different plates, 5 different species. A microwell plate is a plastic plate. But look at the word wells. इसमें well का word use हो रहा है, which basically tells us कि उसमें कुछ wells मौजूद है. In this case, 96 है, which is similar to small test tubes. If I can just point out, just give me a minute. मैं microwell की picture paste करता हूँ, and then it's gonna be a bit more clear. Give me 1 second. ताकि एक बार हमें वो picture दिख जाए, so it becomes a bit more clear कि what are they actually talking about. Okay, this right here, this is an example. Oops. Acha, I have the picture now in mind. Think of a plate, प्लास्टिक की प्लेट, एंड उस प्लास्टिक की प्लेट में बहुत सारे होल्स बने हुए हैं, एज इन होल्स पंक्चर हुए हुए हैं. नाउ थिंक ऑफ एवरी सिंगल होल एज टेस्ट ट्यूब्स. दैट्स अ माइक्रोवेल प्लेट. और यही लिखा हुआ है, इस माइक्रोवेल प्लेट में 96 वेल्स थे, विच आर सिमिलर टू स्मॉल टेस्ट ट्यूब्स. नाउ हर वेल में क्या किया साइंटिस्ट ने, सस्पेंशन डाली बैक्टीरिया की जो स्पीशीज थी उसकी, एक सोल्यूशन डाला जिसमें नाइट्राइट आयंस थे, और न्यूट्रिएंट ब्रॉथ डाला. दिस इज, यू कुड बेसिकली थिंक ऑफ इट एज अ न्यूट्रिएंट मीडियम, ताकि वो बैक्टीरिया को ग्रो करने के लिए न्यूट्रिएंट्स जो चाहिए होते हैं वो उनको इस मीडियम से मिलते रहे. The scientists incubated the microwell plate at 37 degrees for 24 hours. मतलब टेम्परेचर सेट कर दिया इस पे, अब यहाँ से मूव नहीं होगा टेम्परेचर 37 डिग्री सेल्सियस से फॉर वन एंटायर डे. आफ्टर 24 आवर्स साइंटिस्ट ने एस्टिमेट किया नंबर बैक्टीरिया का हर वेल के अंदर बाय मेजरिंग ऑप्टिकल डेंसिटी यूजिंग अ माइक्रोवेल प्लेट रीडर। ओके, फॉर ईच स्पीशीज ऑफ बैक्टीरियम साइंटिस्ट ने रिपीट किया ये एक्सपेरिमेंट। डिफरेंट डिफरेंट कंसेंट्रेशन उन्होंने हर बार लिए नाइट्राइट आयंस के। और फिर साइंटिस्ट ने क्या किया, लोएस्ट कंसेंट्रेशन डिटरमाइन किया जिस पर कोई बैक्टीरिया ग्रो नहीं करे 24 घंटे के बाद। सो फॉर एग्जांपल, अगर उन्होंने कॉन्सेंट्रेशंस ली लेट्स से 0.1 मोल पर डेसीमीटर, 0.2 मोल पर डेसीमीटर, 0.5, तो फिर उन्होंने देखा कि व्हाट्स द लोएस्ट पॉसिबल कंसेंट्रेशन जहाँ पे कोई ग्रोथ ना हो, तो उन्होंने उसको सेलेक्ट किया। अब यहाँ पे ये कह रहे हैं कि उन्होंने टेम्परेचर, पीएच और टाइम को कंट्रोल वेरिएबल के तौर पे यूज किया। यू नीड टू टेल मी टू अदर वेरिएबल्स जो कि कंट्रोल वेरिएबल के तौर पर एक्ट करेंगे। सो लुक एट द प्रोसेस अगेन एंड देन टेल मी।
The concentration of the nutrient broth
हम्म, बिल्कुल सही, क्योंकि हम
and
ग्रोथ मेजर कर रहे हैं बैक्टीरिया की। सो या, एंड
like the volume of the like nitrite ion solution,
बिल्कुल सही, वॉल्यूम ऑफ नाइट्राइड आयन सॉल्यूशन। व्हाई नॉट कंसंट्रेशन ऑफ नाइट्राइड आयन सॉल्यूशन दो?
because we are changing it over here. Like we are looking at the
हम्म, बिल्कुल सही, हम उसको चेंज करके अफेक्ट देखना चाह रहे हैं बैक्टीरिया पॉपुलेशन ग्रोथ पे। तो कंसंट्रेशन एक कंट्रोल वेरिएबल नहीं हो सकता, नाइट्राइट आयन की न्यूट्रिएंट ब्रॉथ का कंसंट्रेशन है। एंड फिर जो हमारा नाइट्राइट आयन है उसकी भी वॉल्यूम एक कंट्रोल वेरिएबल। ओके, द रिजल्ट्स ऑफ द इन्वेस्टिगेशन फिगर 2.1 में हमें दिखती हैं। सो दे हैव जस्ट गिवन अस अ सॉर्ट ऑफ अ बार ग्राफ। इसमें 5 स्पीशीज आ गई बैक्टीरिया की। और फिर नाउ लुक एट दिस, लोएस्ट नाइट्राइट कंसंट्रेशन जिस पर नो बैक्टीरियल ग्रोथ अकर्ड आफ्टर 24 आवर्स। इसका मतलब क्या है? इफ यू लुक एट दिस स्पीशीज ऑफ बैक्टीरिया, इस परसेंटेज पे, या नॉट इवन परसेंटेज, इस कंसेंट्रेशन पे मोल पर डीएम क्यूब की एट विच कोई ग्रोथ नहीं हुआ इस बैक्टीरिया का। लेकिन इस पर स्पीशीज के लिए बैक्टीरिया के, दिस वाज द लोएस्ट कंसेंट्रेशन जिस पे कोई ग्रोथ नहीं हुई। अब इस बैक्टीरिया को हमने डिफरेंट डिफरेंट कंसेंट्रेशन से एक्सपोज किया था, 5, 6, 7, 8। इस पे ग्रोथ हुई, इस पे हुई, इस पे हुई, इस पे नहीं हुई। एंड यही चीज हमने ड्रॉ की। State the type of data represented by the species of bacterium and the lowest nitrite key concentration in figures 2.1. So first tell me this. What's the lowest nitrite key concentration?
continuous.
Continuous, बिल्कुल सही. You basically don't have to tell the number, you have to tell the type of data in दोनों cases के लिए. So yeah, continuous. And what's the other one? Think about it. यहाँ पे rank कर रहे हैं हम species को. So
I think it was called nominal.
नॉ नॉमिनल, बिल्कुल नॉमिनल का दूसरा नाम ऑर्डिनल भी होता है। बट अगेन यू कैन यूज आइदर वर्ड्स क्योंकि रैंकिंग हो रही है स्पीशीज और बैक्टीरिया की। अच्छा जी, द टू स्पीशीज ऑफ सैल्मोनेला, सो सैल्मोनेला एंटेराइडाइस और सैल्मोनेला टाइफीमोरियम। अब इन नामों को प्रोनाउंस करना मुश्किल है बिकॉज दैट्स देयर बाइनोमियल नेम, बट या, तो ये थी दो स्पीशीज ऑफ सैल्मोनेला shown in figure 2.1 are closely related, obviously, क्योंकि इनका जीनस सेम है, सिर्फ स्पीशीज डिफरेंट है। Calculate the percentage difference between the results shown in figure 2.1 for these two species of salmonella. Percentage difference कैसे निकालते हैं? बेसिक मैथ का सवाल है, इसमें कोई बायो यूज नहीं कर रहे हैं। Are you going through the working or are you stuck?
Yeah,
Sorry?
I'm doing it.
Oh, you're doing it. Okay. Sure, take your time.
I'm getting 42. Is that the answer?
Not really. It's supposed to be 86%. Yeah, if you look at it in terms of percentage increase, तो फिर वो बहुत ज़्यादा हो जाता है, which is also an acceptable answer. Could you explain your working for this? ताकि हम देखें working में कहाँ we went wrong. मतलब, how did you reach your answer?
So like first, from the graph, this entry this is like 0.7, and
Okay,
like the the other one it's 5. So like
yeah.
and then we like calculate like the total percentage, like the total of it.
A total of it, as in just tell me it in terms of numbers. मतलब कि you're
Like
saying कि
do we
0.
like add up like all the numbers like 0.5 plus 0.7 and then 3 and then 1 something like that?
नहीं 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 नहीं, not really, not really. अच्छा, इसको सॉल्व करने के लिए हम एक सैम्पल क्वेश्चन देखते हैं. लेट्स सपोज वी हैव अ टेलीविजन, और उस जो टीवी की प्राइस थी दैट्स $40. 2 महीने बाद वो टीवी की प्राइस हो जाती है एट अ 20% डिस्काउंट, और लेट्स से उस टीवी की प्राइस हो जाती है एट एन एक्स परसेंटेज ऑफ डिस्काउंट, एंड दैट इज 22. Could you tell me what's the discount percentage?
18%?
कितना परसेंट?
18?
18. So you just did 40 minus 18, that's 22.
Uh, I did 40 minus 22.
Okay, 40 minus 22. No, this is percentage increase का एक topic. अच्छा, after the class, you could just go on to Google and just write percentage increase IGCSE math. उसमें I know it's been a long time. You'll just get to revise that again. यहाँ पे जरा इसको explain कर देते हैं. A discount is actually just percentage decrease, right? अगर हम discounts की बात करें,
Yeah.
तो अगर हमें परसेंटेज डिक्रीज देखना हो तो उसका फॉर्मूला क्या है? यू टेक द बिगर वैल्यू, subtract it from the smaller value, and divide it by the bigger value. So bigger minus smaller divide by bigger. So 40 minus 22 divide by 40 multiplied by 100, because you want this in a percentage. What's the answer for this? Could you try to calculate this?
It's it's 45.
45. तो इसका मतलब there is almost a 45% डिस्काउंट. इसलिए जब प्राइस अगर 40 होती है एंड उससे 20 हो जाए, मतलब कि प्राइस आधी हो गई है. सो दैट इज व्हाट वी कॉल अ 50% डिस्काउंट. तो दैट इज अ परसेंटेज डिस्काउंट और अ डिक्रीज. यू हैव टू कैलकुलेट हियर द परसेंटेज डिफरेंस. तो अगेन, बड़ी वैल्यू माइनस छोटी वैल्यू डिवाइड बाय बड़ी वैल्यू मल्टीप्लाइड बाय 100. व्हाट इज दिस आंसर कमिंग आउट टू बी?
86.
86 percentage, and that is the answer. Acha, what if you did it the other way around? Matlab, what if you did 5 minus 0.7 divide by 0.7 multiply by 100? इसका आंसर आता 614%. एंड ये भी सही होता. अब इन दोनों में फर्क क्या है? ये जो चीज है, ये है परसेंटेज डिक्रीज. Whenever you're calculating percentage decrease, you put the bigger number as the denominator. Remember, 40 की प्राइस थी 22 कर दी. So 40 minus 22 divide by bigger number 40. क्योंकि हम डिस्काउंट निकाल रहे थे, परसेंटेज डिक्रीज निकाल रहे थे. इफ यू वांट टू कैलकुलेट कि 0.7 से 5 जाने में परसेंटेज इंक्रीज कितना होता है, तो फिर छोटा नंबर डिनोमिनेटर में आ जाएगा. सो दिस इज परसेंटेज इंक्रीज, दिस इज परसेंटेज डिक्रीज. यहाँ पे डिड इट स्पेसिफाई परसेंटेज इंक्रीज या डिक्रीज में से किसी एक भी चीज को, या डिड दे जस्ट से परसेंटेज डिफरेंस?
Percentage difference.
डिफरेंस. तो क्योंकि उन्होंने स्पेसिफाई नहीं किया, तो हम इंक्रीज लिखें या डिक्रीज लिखें, दोनों आंसर्स यहाँ पे acceptable. So you could write this decrease as 86 or increase as 614%. Does this make sense? कोई confusion in this?
No, it's clear.
Okay. अब जरा इसमें आते हैं. हमें इसी फिगर 2.1, ये जो बार ग्राफ वाली फिगर थी, इसी को यूज करके सिर्फ स्टेट करना है, वन वर्ड आंसर देना है. वो कौन सी स्पीशीज ऑफ बैक्टीरिया में जो सबसे ज्यादा अफेक्ट होती है नाइट्राइट आयन से, एंड वो कौन सी स्पीशीज जो सबसे कम अफेक्ट होती है. सो थिंक अबाउट इट. इफ वी टॉक अबाउट द वन जो सबसे कम अफेक्ट होती है, इसका मतलब तो यही हुआ ना कि हमने बहुत ज्यादा नाइट्राइट आयंस लिए, फिर भी कोई फर्क नहीं पड़ा कंसेंट्रेशन पे. दैट्स व्हाट वी मीन बाय लीस्ट अफेक्टेड, राइट?
Yes, so like the most affected is going to be like the first one, the Yersinia something.
हम्म.
Yeah, and then the least affected is going to be the Salmonella typhimurium.
बिल्कुल सही. तो अगर अगर हम यर्सिनिया को देखें, थोड़ी सी नाइट्राइट आयन की कंसेंट्रेशन दी, चेंज हो गए. अगर आप बहुत ज्यादा देंगे तो बहुत ज्यादा चेंज हो जाएगा. तो इसलिए मोस्ट अफेक्टेड इज यर्सिनिया. लेट्स ट्राई टू कॉपी द नेम करेक्टली. यर्सिनिया एंटरओकोलिटिका. और फिर उसके बाद जस्ट मेक श्योर टू कॉपी इट बिल्कुल सही तरीके से, ताकि स्पेलिंग मिस्टेक कोई ना हो. एंड लीस्ट अफेक्टेड, बहुत ज्यादा नाइट्राइट आयंस दिए फिर भी कोई फर्क नहीं पड़ा. दैट्स द बिगेस्ट बार चार्ट. सो दैट इज गोना बी सैल्मोनेला टाइफीमुरियम. ऑल राइट, अब जरा इस पे आते हैं. अब एक बच्चे ने रिजल्ट्स को देखा. अ स्टूडेंट लुक एट द रिजल्ट्स, और फिर उस स्टूडेंट ने एक बात कही. ही स्टेटेड समथिंग. The statement was, consuming a lot of nitrites would improve the health of people, क्योंकि it would help to prevent diseases in the digestive system caused by pathogenic bacteria. You need to suggest 4 reasons कि क्यों ये conclusion सही नहीं है, क्यों ये conclusion गलत है. So you need to relate your answer to the investigation जो कि की गई थी. So do you want me to go to the investigation?
Yeah.
Yeah. तो जस्ट मेक श्योर यू रिमेंबर दिस. अच्छा, अब आते हैं इन्वेस्टिगेशन पे. ये एक काम करते हैं, व्हाट आई कैन डू इज, आई कैन पिक आउट अ स्क्रीनशॉट ऑफ दिस, और फिर हम उसको इन्वेस्टिगेशन वाले उस पे पेस्ट कर देते हैं. लेट्स सी अगर ये कॉपी हो जाता है. आई न्यू इट. ओके, वन सेकेंड. ओके, या लेट्स लुक एट नुक्स एंड कॉर्नर्स. छोटी छोटी डिटेल्स होंगी जो कि स्टेटमेंट के साथ मैच नहीं करेंगी. अजीब अजीब सी डिटेल्स होंगी.
The pH, I think it's different. So like the pH is like different in the body. It's not like 4.8.
डिफरेंट इन द बॉडी या डिफरेंट इन द स्टमक?
Yeah, different in the stomach.
क्योंकि डाइजेस्टिव सिस्टम की बात हो रही है, एंड द मेन पार्ट ऑफ दैट इज द स्टमक. सो या, स्टमक में यू रिमेंबर द पीएच इज लाइक वेरी एसिडिक, क्योंकि द पेप्सिन एंजाइम
Yeah.
या आईजीसीएसई वाली चीज है. तो वहां पे एसिडिक पीएच, उनका ऑप्टिमम पीएच होता है पेप्सिन प्रोटीन, पेप्सिन एंजाइम का. और यहाँ पे तो 4.8 लिया. तो द फर्स्ट थिंग इज कि एक्सपेरिमेंट में पीएच जो यूज हुआ है, the pH used in the experiment is not the same as the pH जो कि स्टमक में हो, या in other words majority part में हो digestive system के. अच्छा, इसीलिए that's one reason कि ये statement सही नहीं है. Anything else? 3 more.
So nitrites could be toxic maybe.
The nitrites could be toxic. थोड़ा सा elaborate. I didn't get you.
Like basically maybe the nitrites could like cause some side effects in like the digestive system.
Could cause some, makes sense, makes sense. Could cause some side effects in the digestive systems. बिल्कुल. अच्छा, इसी से हम तीसरा पॉइंट भी निकाल सकते हैं। नाइट राइड्स साइड इफेक्ट्स कॉज कर सकती हैं कहाँ पे? डाइजेस्टिव सिस्टम में। क्या ये चीज हमने यहाँ पे टेस्ट की कि डाइजेस्टिव सिस्टम पे उसका क्या फर्क पड़ेगा? मतलब कि क्या ये हमने पूरा एक्सपेरिमेंट एक इंसान के डाइजेस्टिव सिस्टम के अंदर किया था जिसकी वजह से हम ये स्टेटमेंट कह सकते हैं, या क्या ये हमने एक लेबोरेटरी में किया था, एक लैब में किया था?
Yeah, so we haven't done it in like a person, we've carried it out in the laboratory.
बिल्कुल सही। सबसे पहले तो ये साइड इफेक्ट्स हो सकते हैं और हमने ये चीज टेस्ट ही नहीं की। We could have tested that by doing that in a person, but we did not do that. Instead, we carried out in a laboratory and not inside of a person. एक और रीजन। Well, I'll try to give you a hint. Look at this. Consuming a lot of nitrites would improve the health of people because it would help to prevent diseases, blah blah blah. तो ये कहना चाह रहे हैं कि ज्यादा नाइट्राइट्स खाने से हेल्थ इंप्रूव होगी। क्या इस चीज का पता हमें एक दिन के अंदर चल सकता है? Which was exactly the amount of time the experiment was for. मतलब कि अगर हम किसी इंसान के हेल्थ के बारे में बात करें कि किसी की हेल्थ इंप्रूव हो रही है, मेंटेन हो रही है, बुरी होती जा रही है, डिटोरिएट होती जा रही है, क्या ये सब काम 2-2 मिनट में होते हैं या डज इट टेक अ कंसिडरेबल अमाउंट ऑफ टाइम फॉर इट टू हैपन?
Assalamualaikum, can you hear me?
यस, वालेकुम अस्सलाम, आई कैन हियर यू।
So sorry, it just my laptop just abruptly shut down.
नहीं नहीं, कोई मसला नहीं, कोई मसला नहीं। अच्छा, yeah, we were on the fourth point. Did you have an idea? अच्छा, till what point were you able to hear me?
You finished, I think, writing the third point, and yeah.
Hmm.
That's-
Acha, so I was gonna give you a hint for the fourth point, but if you already have the fourth point in mind, do you have one?
Yeah, I did have a point. It was like basically so like it's going to be maybe the nitrites they can harm the good bacteria like in the body, like in the stomach.
Hmm. Yes, बिल्कुल सही. The nitrite ions, they just make it the useful bacteria or the good bacteria which you're talking about, जो कि हमारी body के digestive system के अंदर help करते हैं. बिल्कुल सही. So the nitrites may destroy the good bacteria, or a better word would be for the useful bacteria इन द डाइजेस्टिव सिस्टम। अच्छा, एक और चीज, 4 मार्क्स तो हमें यहाँ पे मिल गए, लेकिन हम एक और पॉइंट यहाँ पे लिख सकते हैं और वो ये कि ये पूरा एक्सपेरिमेंट, कुड यू टेल मी कितनी देर में इन्होंने किया था कंप्लीट, स्टार्ट टू फिनिश?
24 hours.
24 आवर्स। एंड लुक एट द स्टेटमेंट, इट विल इम्प्रूव द हेल्थ ऑफ पीपल। क्या हेल्थ की इम्प्रूवमेंट हमें 24 आवर्स में पता चल सकती है? मतलब 24 आवर्स की रिजल्ट की बेसिस पे हमें हेल्थ पता चल सकती है कि इम्प्रूव हुई या डिटोरिएट करेगी?
No.
नो, क्योंकि हेल्थ इंप्रूव होने में, मेंटेन होने में या डिटोरिएट भी होने में बहुत टाइम लगता है। इट समटाइम्स टेक्स मंथ्स, इट समटाइम्स टेक्स इयर्स फॉर हेल्थ ऑफ अ पर्सन टू इम्प्रूव। 24 घंटे के एक्सपेरिमेंट की रिजल्ट की बेसिस पे हम ये नहीं कह सकते कि हेल्थ ऑफ अ पर्सन इज गोइंग टू इम्प्रूव। So yeah, these were the points right here, and that is basically the end of the paper. अब जल्दी से in the meantime I just downloaded another paper. ये इसी ईयर का हमने किया, so we're just doing one by one, step by step, we're going backwards. तो हमने पेपर 51 यहाँ पे कर लिया. I'll send you the PDF for this after the class, and now we're gonna do paper 52. तो जरा इसका क्वेश्चन वन कंप्लीट करने की कोशिश करते हैं आज. Let's read the question. The or better, you should try to read it yourself. मतलब इसमें try to mark down points on the paper which you have. Just take a paper, mark down important points because I want to see how you read the question. वो भी एक जरूरी skill है. So try to read this question and tell me when to move downwards.
Yeah, I'm done. Yes, sir, I've done reading the question.
Acha, the entire question. Okay. So could you tell me what's the independent and the dependent variables?
The independent is going to be like the sucrose solution concentration, and like the dependent, it's going to be the width of this tomato.
बिल्कुल सही. Acha, I'm a bit curious. I hadn't even gone downwards and you read the entire question. That's how fast you read that?
I do read fast, but like I also have the paper with me right now.
Oh, you have this entire paper, this
Yeah,
exact
yeah.
paper with you. Oh, so are you done with this paper? मतलब
No,
कि
like when I, because it's like hard for me to see because sometimes like the bar on Zoom, it sometimes prevents me from reading the question fully. So yeah, I open it side by side.
Okay, makes sense, makes
That's
sense.
all.
Yeah, I was like surprised. नहीं, नहीं. Okay. So sucrose concentration and dependent variable, the width of the stomata. Okay. अच्छा जी. पार्ट टू. स्टूडेंट ने प्रिपेयर किए 20 क्यूबिक सेंटीमीटर के सॉल्यूशंस. एक सॉल्यूशन में 2.5% सुक्रोज था, एक में 5% और एक में 10%. एंड ये सब प्रिपेयर किया गया फ्रॉम अ 20% सुक्रोज सॉल्यूशन, स्टॉक सॉल्यूशन. किस तरीके की डाइल्यूशन है ये? इज दिस प्रोपोर्शनल और सीरियल?
Serial?
दिस इज एक्चुअली प्रोपोर्शनल डाइल्यूशन. सीरियल डाइल्यूशन हम उस टाइप की डाइल्यूशन को कहते हैं जहां पे यू कीप हाफिंग द डाइल्यूशन. सो फॉर एग्जांपल, इफ द डाइल्यूशन इज 10%, फिर एक सेकंड, एक सेकंड, एक सेकंड, वन सेकंड. यस, वेट वेट वेट, यू राइट, दिस इज सीरियल डाइल्यूशन. क्योंकि 10% से फिर हम 5 पे गए, फिर 5 से 2.5 पे गए, व्हिच इज एग्जैक्टली दिस. कभी कभार इन द क्वेश्चन, इफ अगर स्टॉक सोल्यूशन मेंशन्ड हो 20, एंड देन फिर उन्होंने सॉल्यूशंस लिए 3, 7 एंड 11 एंड देन 13, ये किस टाइप की डाइल्यूशन है?
This is proportional.
दिस इज प्रोपोर्शनल. ये मेरा मेन मकसद था समझाने का कि प्रोपोर्शनल एंड सीरियल में द ओनली डिफरेंस यू विल सी इज दैट जो कंसेंट्रेशन परसेंटेजेस बनी है सोल्यूशन की, उनके बीच में कोई कॉमन रिलेशनशिप होगा, कोई मल्टीपल होगा. जैसे कि यहाँ पे मौजूद था, व्हिच समहाउ आई ओवरलुक्ड, 10, 5 एंड 2.5, कि हर दफा डिवाइड बाय 2 हो रहा है. लेकिन प्रोपोर्शनल में ऐसा कोई लिंक ऐसा होगा नहीं. अच्छा, कंप्लीट द डिस्क्रिप्शन, मतलब बेसिकली हमें डाइल्यूशन मेथड एक्सप्लेन करना है फॉर द 2.5 एंड 5% कि उनमें है, उन चीजों को हमने बनाया कैसे. The student mix dash cubic centimeter of 20% sucrose with dash cubic centimeter of water to make a 2.5% solution. How would you solve this?
Can we do C1 V1 equals C2 V2?
Let's try. अगर हम and let's see what happens. C1 V1 equals C2 V2. इसमें C1 का मतलब क्या होता है?
The initial concentration.
The stock solution की concentration. बिल्कुल. Now you could take this as percentage या just convert every single percentage you can find to a decimal. तो 20% को let's take this as 0.2. तो 0.2 हमने ले लिया. V1 क्या होता है?
The initial volume.
The initial volume of the stock solution जो हम extract करना चाह रहे होते हैं, which is what we have to write down. So let's write this as V1. What now? What's C2 and V2?
The final the concentration and the final volume.
Yeah. So this is the final concentration, and जो हमारे पास मौजूद है, this is 0.25, and then the final volume. Do you have the final volume?
Yeah, we do.
And what's the final
20
volume?
centimeter cube.
20 centimeter. एक second. Yeah, 20 centimeter cubed. Okay. Yeah, from right here. Now what's gonna be V1 in this case? Matlab, what amount of this percentage of stock solution are you gonna take for the first solution? So basically, all you have to do is 0.25 times 20 over zero point 0.2.
2.5.
बिल्कुल सही 2.5 एंड अगर 20 सेंटीमीटर्स का बनाना है उसमें से 2.5 हम सब्ट्रैक्ट कर देंगे हाउ मेनी क्यूबिक सेंटीमीटर्स ऑफ डिस्टिल्ड वाटर
17.5.
बिल्कुल सही नाउ लेट्स डू दिस अगेन अगर हमें 20% की सुक्रोज स्टॉक सॉल्यूशन मिला हुआ है दैट इज 0.2 वी डोंट नो व्हाट v1 इज वी वांट टू क्रिएट अ 5% स्टॉक सॉल्यूशन जिसकी टोटल वॉल्यूम 20 cubic centimeters हो सो 0.5 times 20 which is just half of 20 divide by 0.2
5 centimeter cube and then 15 centimeter cube of water.
बिल्कुल सही ओके अब आ गया the big question, the 5 mark question. Now this paper, I'm surprised it just has a 5 marks of the main question. Normally this is 7, 8, 9 marks, लेकिन it's a bit small, which probably tells us कि ये paper थोड़ा सा लंबा होने वाला है. But okay. The student observed the stomata on the microscope की जो slides होती हैं using high power objective lens. This is basically the name of the lens जो कि एक light microscope में मिलती हैं. If you've used a light microscope, you might have seen, right? वो rotating lens होती हैं तीन तीन.
Yeah.
Yeah, so one of these is called the focal lens, one is the objective lens, and तीसरी lens भी एक होती है. लेकिन we just use the high power lens to solve all of our P3 के सवाल. Objective lens यहाँ पे use outline a method the student could use क्या करने के लिए investigate करने के लिए the effect of the sucrose solutions in table 1.1 on the width of the stomata in the leaves of the plantain lily. Your method should be set on a logical order, be detailed enough for another person to follow it. ये हर सवाल में सेम चीज होती है ये जरूरी है details of how to prepare the microscope slide should not be included कि हमें लाइव स्पेसिमेन नहीं लेना डेड स्पेसिमेन लेना है फिर उसको हम एक टेप के ऊपर पेस्ट करेंगे स्लाइड प्रिपेयर करेंगे ये सब नहीं लिखना you have to assume कि microscope की slide is already prepared for you and how will you use that मतलब how will you use the stomata on the slides to show कि इसका क्या effect है और इसका क्या रिलेशन है विद सुक्रोज सॉल्यूशन कि मतलब अगर हम सुक्रोज सॉल्यूशन को चेंज करते हैं तो स्टोमेटा की विद के साथ क्या होता है सो टेक योर टाइम विद दिस एंड टेल मी वंस यू आर रेडी विद द फाइनल आंसर
Could you just show the question?
या
Yeah, I'm done.
Hmm. So could you explain your answer?
Yeah, okay. So first we are gonna like mention the independent, dependent, and the control variables. Like the independent is going to be the sucrose solution. The dependent is going to be the width of the stomata, and for the controlled, we could say like the volume of the sucrose solution. And yeah, so like basically for the method, we're going to be like first we're going to prepare the sucrose solution, like all the sucrose solution concentrations, and for the
Yeah.
method we are going to leave the like the tissues in like the sucrose solutions for like the same time. and
Okay.
meanwhile we could we're going to like calibrate. I think we used to calibrate like the eyepiece graticule. I think it was,
Hmm.
yeah,
बिल्कुल
eyepiece
सही.
graticule. And then we're going to like put the tissue like we're going to put it like under the lens, and then we're going to measure the width of the stomata. And like at the I think if we measure it like from the where it's like the thickest, or like the, what do you call it? I think widest, I think.
The widest, yes. The
Yeah.
stromatal aperture यहाँ सबसे ज़्यादा wide होगा.
Yeah.
Yeah.
Yeah, and then basically we could and then we could replicate the results at least 5 times to obtain a mean and remove anomalies.
Okay.
And like we could say that that this is like a medium risk experiment, because like the um sucrose solution could like cause maybe allergies, or like it could be an irritant, and so we could wear gloves.
बिल्कुल सही. So यहाँ पे I'm just completing writing down your method. So measure the width of the stomata from the widest point. अच्छा, could you just repeat your repeat वाला point? I missed that. Repeating the experiment वाला point.
Yeah, so we can replicate the results at least 5 times to obtain a mean and remove anomalies.
तो यहाँ पे obtain a mean का मतलब क्या है? मतलब हम क्या mean value निकालना चाह रहे हैं?
Like the width of this tomato, we could like calculate a mean for that.
So what is the method you're thinking of? Is that कि हम एक स्टोमेटा को डालेंगे और फिर उसी स्टोमेटा को हम मेजर करेंगे डिफरेंट डिफरेंट एंगल से उसका विथ, या आर यू सेइंग कि हम अलग अलग स्टोमेटा को डालें सेम सुक्रोज कंसेंट्रेशन में और फिर उन अलग अलग स्टोमेटा की अलग अलग वैल्यूज विथ की हम मीन लें? सो आर यूजिंग वन स्टोमेटा और मल्टीपल स्टोमेटा?
We could use multiple.
We could use multiple stomata. बिल्कुल सही. You can remember what was your dependent variable. You're measuring the width of stomata. अब stomata की width affect होनी चाहिए सिर्फ concentration of sucrose से. तो इसका मतलब अगर हम different stomata लेंगे from different leaves, you put them in the same sucrose solution, you should get the same effect on each stomata. तो you can use different stomata भी. And फिर एक से let's suppose हमें width मिलती है 4 centimeters. एक से 3.8, एक से 3.7, एक से 4.3, एक से 4.2, इस सब का हम एवरेज ले सकते हैं. मेथड नंबर वन. या मेथड नंबर टू, यूज द सेम स्टोमेटा एंड डिफरेंट डिफरेंट एंगल से हम उसकी लेंथ मेजर करें. बट अगेन दिस वुड बी अ बेटर वन. सो replicate results by using different stomata and placing them in the same sucrose solution. And yeah, the अगला वाला point is बिल्कुल सही कि you do that to avoid any anomalies or any anomalous results. So let me just complete this. Placing them in the same sucrose solution. And we do this, of course, don't write this in the exam. We do this to avoid any anomalous results. Avoid this. अच्छा, फिर उसके बाद आखिरी वाला स्टेप, यू टॉक्ड अबाउट द रिस्क्स. तो यू सेड कि सुक्रोज सॉल्यूशन कुड बी एन इरिटेंट जिसकी वजह से हमें ग्लव्स यूज करने चाहिए. अगर हम स्टोमेटा को विथ उसकी मेजर कर रहे हैं, तो डज दैट मीन हमें स्टोमेटा को सबसे पहले लीफ को कट करना पड़ेगा ताकि वो स्टोमेटा दिखे हमें?
Yeah.
तो इसका मतलब यू हैव टू बी यूजिंग अ नाइफ या द स्मॉलर वर्जन ऑफ अ नाइफ जिसको स्कैल्पल बोलते हैं. सो इफ यू यूजिंग दैट, उसका एक रिस्क है कि कट्स भी लग सकते हैं. सो व्हाट यू शुड डू इज यू शुड कट इट अवे फ्रॉम द हैंड. इसका मतलब कि हमें बेयर हैंड्स को यूज नहीं करना, मतलब ग्लव्स, अनदर पॉइंट. और बिल्कुल हमने हाथ के प्रॉक्सिमिटी में कट नहीं उसको करना, उसको बोर्ड पे रखना है. और फिर बोर्ड पे रखने के बाद उसको हमें कट करना है. ऐसा नहीं कि हमने एक हाथ में लीफ पकड़ी हुई है, दूसरे हाथ में स्कैल्पेल है और हम कट कर रहे हैं. नो, दैट्स अ रिस्क, क्योंकि हाथ में कट्स भी लग सकते हैं. सो दिस, इसका रिस्क हो सकता है कट्स. एंड इसके लिए प्रिवेंशन इज टू कट ऑन द बोर्ड या कट द लीफ बाय प्लेसिंग इट ऑन द बोर्ड. एंड यू आर राइट, सुक्रोज सोल्यूशन भी एक इरिटेंट हो सकता है जिसके लिए हमें ग्लव्स यूज करने चाहिए. अच्छा, इट्स गुड कि यू डिड नॉट जस्ट फॉलो द टेम्पलेट एज इन वर्ड बाय वर्ड बाय वर्ड. फॉर एग्जांपल, टेम्पलेट में हमने एक बात की थी कि इंडिपेंडेंट वेरिएबल को चेंज कैसे करना है. अब यू कुड हैव सेड कि टेम्पलेट में तो ये मेंशन था कि इंडिपेंडेंट वेरिएबल को चेंज कैसे करना है, तो यहाँ पे चेंज ऐसे करेंगे कि डाइल्यूशन करेंगे. But putting that point here doesn't make sense because in the previous question उन्होंने वैसे ही explain कर दिया dilution का पूरा process. So there's no need to write how to change the independent variable in this question. So you have to be adaptable, you have to be flexible. एक ही template को that's a resource for you to help. ऐसे नहीं कि हम उसी को use करके हर आंसर बना देंगे. That's just something we can look at time and time again. Okay, any confusions from this? Your answer was बिल्कुल सही for 5.
No, it's clear.
Okay, now let's go to this. You need to predict the effect कि क्या फर्क पड़ेगा अगर हम सुक्रोज कंसंट्रेशन को इंक्रीज करें फ्रॉम 0 to 20 on the width of the stomata in the leaves of the plantain lady. And you also need to explain your prediction कि अगर परसेंटेज इंक्रीज हुई तो सुक्रोज की विथ पे क्या फर्क पड़ेगा. थोड़ा सा इसमें होम्योस्टेसिस वाला कंसेप्ट आ जाएगा, द थिंग वी लर्नड अबाउट गार्ड सेल्स में. या
So like basically as like the sucrose concentration increases, like the width of the stomata it decreases because like as like the as the sucrose enters the like the cells and water leaves the guard cells,
ओके.
because water travels like down a water potential gradient via osmosis, so it leaves the guard cells.
ओके, उसके बाद. So if the water leaves the guard cells, what's gonna happen to the stomata in this case?
Then the width of the stomata it decreases.
It decreases क्योंकि जो stomatal aperture है वो उसकी size जो है वो कम होती जाती है because the guard cells is now covering the majority part of the aperture जिसके जरिए चीजों ने अंदर बाहर होना था. That's basically just the stomata. So leaves the guard cells by osmosis, causing the width of the stomata, your stomatal aperture, to decrease. अच्छा, let me ask you this, and you can use this word in your exams. थोड़ा सा इससे तीन चार words बच जाते हैं. That's one word for this entire thing. ये पूरी चीज लिखने की बजाय हम एक word लिख सकते हैं, थोड़ा सा time भी बच जाता है. Could you tell me the difference between endosmosis, हमने ये किया था, and exosmosis? इसमें फर्क क्या है? Look at the words that's being used. What does the word endo mean? Does the word endo mean going in or going out? For example, if you look at an endothermic reaction, क्या energy taken in होती है या energy released होती है to the surroundings?
Taken in.
Taken in. So the word in refers to endo. You could remember it by endo is similar to the word enter. मतलब कि something is going in. Exothermic reaction में energy release होती है taken in.
Release.
And you can remember this by the word exit. Exo, exit. तो एंड ऑस्मोसिस का मतलब है कि ऑस्मोसिस तो हो रहा है, लेकिन पानी अंदर मूव कर रहा है, द वाटर इज मूविंग इनटू द सेल्स, सो इन दिस केस इनटू द गार्ड सेल्स, सो दैट्स एंडोस्मोसिस। यहाँ पे पानी गार्ड सेल से बाहर जा रहा था, इज दैट एंडोस्मोसिस और एक्सोस्मोसिस?
Exosmosis.
Exosmosis. Now, this is part of your syllabus, but सिर्फ एक दो ही जगह mentioned in your entire book, and it's again completely up to you if you want to use that or not. But yeah, endosmosis and exosmosis. Okay जी, अब अगले क्वेश्चन पे आता हूँ. Will you read this question through and let me know once you have read it for your answer for part one. Just explain your method while you're giving me the answer.
Yeah, I've read the question.
So now you need to use figure 1.3 to calculate the stomatal density on the lower epidermis, and they're asking you to use the area formula and pi ke liye ye value. Give your answer to the nearest whole number and show your working. So what's your working gonna be like?
So like we could like calculate like the we could measure like the radius or like the diameter,
Okay.
and then
So
we'll
do you have the hard copy of the paper with you or the soft copy?
I have the soft copy.
Soft copy. So I can tell you the radius now because you obviously won't be able to measure it on the laptop or screen jo bhi hai. So I'll tell you the radius. The radius of the picture or the diagram is 4.25 centimeters. Now, what are you going to do with this value?
Will we calculate like
Yeah,
the area?
the area. Yes, क्योंकि हमें area का formula use किया हुआ है. Yes. And उसके लिए pi r square करेंगे. So that's pi times 4.25 squared. And what is that value equal to?
It's 56.716.
56.716. Now look at what the question is asking for. Stomatal density. अब अगर हम नॉर्मली डेंसिटी का फॉर्मूला देखें, इट्स द रेशियो ऑफ मास टू वॉल्यूम. यप, डेंसिटी इक्वल्स मास डिवाइड बाय वॉल्यूम. स्टोमेटल डेंसिटी का यहाँ पे मतलब होगा इट्स द नंबर ऑफ स्टोमा और द नंबर ऑफ स्टोमेटा डिवाइडेड बाय वॉल्यूम. सो यहाँ पे लिखा हुआ है नंबर ऑफ स्टोमेटा एंड देन यू जस्ट नीड टू डिवाइड दैट बाय वॉल्यूम. कुड यू काउंट कितने स्टोमेटा प्रेजेंट है यहाँ पे? How many stomata in the picture?
12? Oh,
Let's see. What? Did you say 30?
yeah.
Yes, it's gonna be 13 stomata. But now look at this. हमने फॉर्मूला लिख दिया नंबर ऑफ स्टोमेटा डिवाइड बाय वॉल्यूम. कहाँ से देख के? डेंसिटी का फॉर्मूला जो हमें याद है उससे देख के. बट नाउ लुक एट द यूनिट, मिलीमीटर्स इनवर्स टू. क्या इसका मतलब है कि वो डिनोमिनेटर में एरिया यूज कर रहे हैं या वो वॉल्यूम यूज कर रहे हैं?
Volume. The area, I think.
द एरिया, बिल्कुल सही. लेकिन फिर हमने यहाँ पे वॉल्यूम क्यों लिखा? बेसिकली whenever you write down the formula for density, let me write this down and let's explain this. Mass over volume. अब यहाँ पे you might have heard of many different types of density. For example, let's see. Chemistry में have you heard about charge density?
Yeah.
Yeah, so charge density क्या था? Charge density is कि एक एटम के अंदर या एक आयन के अंदर अगर उस आयन का एरिया अगर हम लें या साइज लें तो उसके अंदर कितना चार्ज है. So that's the charge divided by area. Now look at this. Volume and area, ये तो different different चीज है. लेकिन फिर हमने यहाँ पे एरिया क्यों यूज किया, वॉल्यूम क्यों नहीं? It's because area and volume are the same thing in terms of the fact कि वो एक given space को measure कर रहे हैं, isn't it? Volume उस space को measure कर रहा है 3D में, and area उस space को measure कर रहा है 2D में. So for example, can you calculate the volume of a square? Is that possible?
No.
नो, क्योंकि स्क्वायर एक 2D शेप है, तो उसका अगर हमें रीजन कैलकुलेट करना है कि कितना उसने ऑक्यूपाई करा हुआ है स्पेस, तो उसके लिए हम वॉल्यूम नहीं यूज करेंगे, उसके लिए हम एरिया यूज करेंगे. वहीं पे इफ आई टेल यू टू कैलकुलेट द वॉल्यूम ऑफ अ क्यूब, कैन यू डू दैट?
Could you repeat?
इफ आई टेल यू टू कैलकुलेट द वॉल्यूम ऑफ अ क्यूब, कैन यू डू दैट?
Yeah, I can.
You can, because that's a 3D shape. So it basically depends on क्या चीज 2D है and क्या चीज 3D है, और उस हिसाब से हम वॉल्यूम यूज करते हैं या हम जो एरिया है वो यूज करते हैं. अब यहाँ पे एक 2D शेप है because that's a diagram. तो यहाँ पे there's no point of using volume, so we just use area. But always remember, both of these quantities are just there to measure space. एक और एग्जांपल लेते हैं. In physics, have you learned number density when you were learning AS के अंदर charge drift velocity? Remember this?
Yeah.
तो नंबर डेंसिटी क्या था? नंबर ऑफ चार्ज कैरियर्स पर यूनिट वॉल्यूम. अब वहां पे हम वॉल्यूम क्यों यूज कर रहे हैं? क्योंकि अ वायर इज अ 3D ऑब्जेक्ट. वहां पे एरिया मेजर करने का फायदा नहीं है, वहां पे हम वॉल्यूम मेजर कर सकते हैं. दिस इज अ 2D डायग्राम, तो वी मेजर एरिया है. So 13 stomata divide by 56.716, the area of the diagram, which is basically a circle. What is this answer equal to?
It's 0.229.
0.229. अब ये जो हमने वैल्यू निकाली है स्टोमेटल डेंसिटी की, डज इट इंक्लूड मैग्निफिकेशन या इज दिस विदाउट मैग्निफिकेशन?
Without magnification?
तो यू नीड टू इंक्लूड द मैग्निफिकेशन है. क्यों? क्योंकि ये जो डायग्राम है, ये भी तो एक मैग्निफाइड इमेज है, इजंट इट? दिस डायग्राम इज नॉट द रियल लाइफ इमेज. दिस इज नॉट एक्चुअल. दिस इज अ डायग्राम इमेज. मतलब इसमें मैग्निफिकेशन शामिल है. अगर हम यहाँ पे मैग्नीफाई नहीं करते, क्या हमें 13 स्टोमेटा दिखते कभी? We would have found much more than 13, right? Because we would have taken a zoom out photo if this was not magnified.
Yeah.
Yeah, so it's the same thing कि अगर हम अब 13 stomata को use करें as the number, you need to take into account of the magnification. Could you tell me what's the magnification used over here? Magnification कैसे calculate करते हैं?
It's going to be the image size over the actual size.
बिल्कुल. And यहाँ पे look at this. You have a scale bar. What is the scale bar representing?
I think
Is it representing the actual length or is it
the actual
representing
length.
the... Okay, it is representing the actual length. Are you sure? ये स्केल बार इसलिए नहीं होता कि हम मेजरिंग स्केल को इसके ऊपर रखें तो हमें हमारी एक्चुअल लेंथ मिलेगी, एंड फिर ये हमें बता रहा है कि जो डायग्राम की लेंथ है वो क्या होनी चाहिए.
Mhm.
सॉरी.
I think so. I think this chapter is a bit thoda sa, it's like
Yeah, it's
complicated. Yeah.
magnification. Yeah, it's like the reason is बहुत से बच्चों को ये मुश्किल क्यों लगता है, क्योंकि ये एएस का भी पहला चैप्टर था. सो लाइक दैट्स द फर्स्ट थिंग ए लेवल्स में दे लर्न, तो इसलिए वो थोड़ा सा याद करने में मुश्किल होता है. सो ये यहाँ पे हम मैग्निफिकेशन भी कैलकुलेट करेंगे. नाउ ऑफ कोर्स यू वुड नॉट बी एबल टू यूज रूलर हियर. सो एंड यहाँ पे वैल्यूज भी लिखी हुई नहीं होती, यू नीड टू कैलकुलेट देम योरसेल्फ. इवन आई एम यूजिंग अ स्क्रीन, मैं भी मेजर नहीं कर सकता. सो जो भी मैग्निफिकेशन होती है, उसको हम जब स्टोमेटल डेंसिटी में अप्लाई करते हैं, तो फिर आंसर आता है 367 millimeter square. All you need to do is you need to assume this is your magnified image. Magnified image की density. And now you just need to get the actual image की density. So this right here is this value. This right here is this value. एंड मैग्निफिकेशन हम इसके जरिए निकालते हैं। Does that make sense?
Yeah, it does.
कोई ओके, अब जरा पार्ट टू में आते हैं। You need to suggest how this investigation could be improved to increase the confidence in your answer. You're calculating the stomatal density.
We could view it like from different angles.
बिल्कुल सही, यू कैन व्यू इट फ्रॉम डिफरेंट एंगल्स। उससे क्या फायदा होगा? उससे फायदा ये होगा कि यू विल बी एबल टू गेट डिफरेंट एंगल्स ऑफ द डायग्राम। नाउ इफ यू लुक एट इट फ्रॉम दिस वे, if you look at now, I don't know how to make an eye, but yeah, if you look at it from this way, then you're gonna get to see stomata जो यहाँ भी present हो सकते थे। It's just placing it on different positions, placing the slide on different positions, or using the same slide and different angles. So viewing the slide, जो microscopic हमारी slide थी, from different angles. Okay, so I see you're good with this one more mark questions. यहाँ पे बच्चे ज़्यादा struggle करते हैं, so it's good that you're going good with this. That this is basically like what makes or breaks हमारा P5, क्योंकि इतने one mark के आते हैं कि बच्चों को समझ नहीं आता अच्छा ये क्यों है। And the most which people hate, which I personally also dislike, suggest के questions. Suggest के questions का इतना ज़्यादा range होता है कि answers कुछ भी हो सकते हैं, and you need to make your answer as close as possible to the marking scheme. Yeah, that's very good. अच्छा, पार्ट थ्री, अगेन फिर से सजेस्ट, लेट्स सी। अ डिफरेंट प्लांट की स्पीशीज हैड अ लोअर स्टोमेटल डेंसिटी देन द वैल्यू कैलकुलेटेड फॉर पिछले वाला प्लांट ले ली। यू नीड टू सजेस्ट कि इन्वायरमेंटल कंडीशंस अलग अलग प्लांट स्पीशीज की कैसे वेरी कर सकती हैं, जिसकी वजह से डिफरेंट आंसर्स हैं। मतलब कि जो प्लांटेन लिली था, इसकी स्टोमेटल डेंसिटी में और ये दूसरे वाले स्टोमेटल डेंसिटी में फर्क था, लेकिन जो एनवायरमेंटल कंडीशंस थी, हाउ डिड दे प्ले अ रोल इन मेकिंग दीज टू वैल्यूज डिफरेंट? दैट्स व्हाट यू नीड टू एक्सप्लेन। So let me give you an example and then you can tell me the remaining points. Let's say अगर हमने दो प्लांट्स लिए हैं, let's call this plant A and then let's call this plant B. Plant A को and plant B को we have subjected them to different environmental conditions. प्लांट ए जिस रीजन में ग्रो करता है उस रीजन में ह्यूमिडिटी बहुत लो है, एंड प्लांट बी जिस रीजन में ग्रो करता है उसमें ह्यूमिडिटी बहुत हाई है। वेयर डू यू थिंक इज ट्रांसपिरेशन गोना बी हायर?
When there's low humidity.
बिल्कुल सही, क्योंकि ह्यूमिडिटी का मतलब क्या होता है कि हवा के अंदर, एटमॉस्फेयर के अंदर कितने वाटर के पार्टिकल्स मौजूद हैं। जितने कम वाटर के पार्टिकल्स होंगे, जितनी लो ह्यूमिडिटी होगी, उतने ज्यादा जगह मिलेगी उन न्यू वाटर पार्टिकल्स को which are going to be lost by transpiration. So imagine this, so many water particles around the leaf, this happens in high humidity. So here, जब इतने सारे वाटर पार्टिकल्स होंगे तो ट्रांसपिरेशन का रेट भी कम होगा, क्योंकि अब नए वाटर पार्टिकल्स को जगह ही नहीं मिल रही इवेपोरेट होने के लिए, व्हिच वर गोइंग टू बी इवेपोरेटेड फ्रॉम द लीफ। यहाँ पे लो ट्रांसपिरेशन है। तो जब ट्रांसपिरेशन लेस है एंड यहाँ पे ट्रांसपिरेशन ज्यादा है, वुड इट मेक सेंस टू हैव अ लॉट ऑफ स्टोमेटा है?
No.
नो, क्योंकि ज्यादा स्टोमेटा का मतलब होगा कि यहाँ पे ट्रांसपिरेशन तो वैसे ही लो हो रही है। तो वी नीड टू मेक श्योर कि यहाँ पे ट्रांसपिरेशन का रेट कम किया जा सके, सो हैविंग डिफरेंट नंबर्स ऑफ स्टोमेटा। इस तरीके से स्टोमेटल डेंसिटी भी चेंज हो जाएगी। तो दिस वाज वन रीजन और वन environmental condition based on which stomatal density is different. Could you think of something else?
High temperature and maybe high wind speed.
Okay, how does high temperature affect stomatal density?
When there's high temperature, when there's high temperature, then there's also less rate of transpiration.
Are you sure?
Mm. Oh, it's
When
a higher rate of transpiration.
Yeah, yes, because the plants use transpiration as a cooling mechanism. तो वो cool करने के लिए अपने आप को पानी lose करते हैं. So that's more transpiration. So where is there gonna be a lesser stomatal density?
In
But
the low temperature ones?
shouldn't that be the high temperature? Because think about it, right? High temperature का मतलब बहुत ज्यादा transpiration. अब अगर हम बहुत ज्यादा स्टोमेटा भी वहां पे रख देंगे तो वी आर जस्ट इनकरेजिंग दैट, राइट? वी आर इनकरेजिंग कि ज्यादा से ज्यादा ट्रांसपिरेशन हो। अगर हम वहां पे लेस टोमेटो रखेंगे तो आरंट वी लिमिटिंग द अमाउंट ऑफ ट्रांसपिरेशन जो कि हाई टेम्परेचर में होती है।
Yeah, we are.
यार तो हाई टेम्परेचर वाले प्लांट को लेस टोमेटल डेंसिटी होगी। लो टेम्परेचर वाले में तो कोई मसला ही नहीं है क्योंकि वहां पे ट्रांसपिरेशन का रेट इतना हाई होता ही नहीं है। सो वी कैन पुट टन्स एंड टन्स ऑफ स्टोमेटा देयर बिकॉज रिमेंबर स्टोमेटा सिर्फ ट्रांसपिरेशन में यूज नहीं होता, वो यूज होता है कार्बन डाइऑक्साइड एंड ऑक्सीजन की गैस एक्सचेंज के लिए भी। तो लो टेम्परेचर है, ट्रांसपिरेशन ज्यादा होने का कोई रिस्क नहीं है, तो हम बहुत ज्यादा स्टोमेटा यूज कर सकते हैं ताकि बहुत सारी फोटोसिंथेसिस हो जाए। अच्छा, you also said wind speed. So how does wind speed affect stomatal density?
Higher the wind speed, then higher the rate of transpiration.
Mhm.
So the stomatal density is going to be higher in like A, I think.
Again, it's the opposite. It's
Oh,
gonna be higher in B. अब इसको देखते हैं ऐसा क्यों? High wind speed, you're right until वो वाला point कि high transpiration. अब transpiration ज़्यादा होने वाली है। Transpiration तो होती स्टोमेटा के जरिए, तो अब transpiration को कम कैसे करें? कम स्टोमेटा यूज करिए। So we're just decreasing the number of stomata, hence the stomatal density. Does that make sense?
it does.
Yeah. So you could say either low humidity or high temperature and then high wind speed. इन सब के जरिए स्टोमेटल डेंसिटी कम होगी जिसकी वजह से लेस ट्रांसपिरेशन के जरिए there's gonna be less water lost. So less stomatal density and then less water lost by transpiration. Right, that was it for today from my side. Good luck to all of you guys who are preparing for the P5 exam, either if this is for variant 1 or variant 2, because variant 1 and 3 are the same. And also, good luck to those guys who are preparing for composites. For those giving composites, they also have a Bio P2 tomorrow. I have uploaded a past paper for Bio P2. Make sure to check that out too. Unfortunately, I would not be able to do predictions. I really don't like making videos of predictions because what that does is if I give out a series of questions that I predict are gonna come, students are just gonna revise that and then go into the exam. And now no one has a crystal ball, no one's gonna tell you what's gonna come in the exam. If they are telling so, they're baffling, they have no absolutely no idea what they're talking about. Trends are something like you can statistically predict what's gonna come and what's not gonna come, but you can't really say for sure, right? And there's no point of saying something that's not for sure. So yeah, unfortunately, I wouldn't really do any predictions for this moment. Maybe in the future, if I have a good idea of what's coming in the exam, I could, but unfortunately not for today. If you have any questions from any part of P5 or P2, let me know in the comment section. I'll be able to help you out. Good luck for tomorrow and let me know how your exam goes once again in the comment section or on my Instagram, which is labeled in the thumbnail of this video. Thank you. Allah Hafiz.